and if you have done, if you have performed well in some of the 6 assignments, so it's enough. So we
Okay,
won't
sir.
consider mock.
Sir,
Thank
actually,
you.
sir, just a clarification.
Mm.
Means the prior to this term, they announced some announcement. In that, it was mentioned 7 assignment. Any amendment has taken place, sir, for 6 assignments?
Okay, is it 7? I don't know. I just said 6 because previously it was 6. I don't know about
Okay, okay. So
This
still,
term is 7.
best of 7, is it?
yeah.
So, okay.
Yes, sir.
So if you have done 7 assignments pretty decent, so don't worry about mock. So this is an
Okay, sir.
extra thing here. Okay.
Okay,
Okay.
sir.
So okay, let me.
Sir, week 10 deadline extended not.
Yeah, week 10 deadline will extend. Don't worry.
Okay, sir.
As of now, it is not extended, right?
Yes, sir.
Okay, it will extend. It will extend to somewhere around
16.
16 or 18. So
Yes, sir.
okay, you will get an announcement. Don't worry about that also. Okay, what I want you guys to do is take a 3-digit number, any 3-digit number, and multiply it by 91. So you can use calculator also. Just multiply it by 91 and tell me the last 3 digits of your final number.
The 909.
90.
909, is it? So your number is 899.
No, sir. It's 999.
It's 999.
Yes, sir.
Just a second. Ah, yeah, sorry. Oh, I failed.
So how does this work?
It's just a mathematical trick. That's it. Let me do some correct numbers, and I will finish.
Okay, sir.
195, sir.
195.
Yes.
Okay. $245.
145, sir.
Arey yaar. I'm missing the last number. Last digit. How can I miss? Yeah, 145. Okay, sorry. Okay, one more, please.
How,
Arey.
sir, this is?
Huh?
How it works?
I will tell you.
ये सब बचपन
512,
में
sir.
करके रहते थे खेल खेल में.
512.
Okay, this I won't fail, definitely. I hope so. 632.
Yes, sir.
Correct. Yeah, thanks. Okay, this how this works is basically it's just related to mathematics. So whatever number I take, so suppose I take 342. So I'm multiplying this 342 with 91. Right? So this will be done by you. What I will do is I will multiply this with 11. Okay. See, look at this 91 times 11 will be 1001. So when 342 is multiplied by 1001, we will get 342 comma 342. So you are going to say me this, you are going to say me, not this, you are going to say me the number when multiplied by 11, you are going to say me one number. When that is multiplied by 11, I'm going to get the last 3 digits as 342. You can check it again and again. This will work. So this part you will do, and later I ask you the last three numbers, last 3 digits. So what that will be? That will be 2. So when I perform this thing, 2, 4, 3, 8, 136, 7. 27, 30. So 2, 2, 10, 0, 2, 2. Right? When I multiply 0, 2, 2 with 11, I will get 2, 2, 2, 2. Array. Some mistake again. Again, I am missing the third digit.
It will be 242.
Which will be?
242, right?
This will be 242, but I taken 342, right?
Mm,
I'm again missing one number somewhere. So this is okay. This is 12 and this is 122. Okay.
Yeah, there is one.
This will be 122, 1, 1. So I will get 342. So whatever, once I multiply 11 with the number you said, I will take the last three digits of it and it will be your three digit. This will work because of the product of 91 and 11 is 1001. Okay. So this is one small trick. See, uh, it will be good if you, not you,
so,
I am maybe
so,
interested. Huh?
so just a clarification.
Hmm.
122 times 11 will be 1342, right?
Yeah, 1342, and I will take the last three digits.
Oh, okay, okay.
So what you have to do is, as you are taking the last three digits of the other guy, just multiply that number with 11, and you tell the last three digits of that,
Okay.
and that will be his number. Okay.
This is an interesting trick, sir.
Yeah. So there are many tricks. There are many tricks. So if you want to
Good
fall in love
to
with mathematics, or
good to start with. It is making us interesting.
yeah. Okay. So yeah, see, in the next sessions onwards, I will try to bring up one
Good,
interesting
sir.
tricks like this, and we will start.
Yeah.
Okay. So yeah, so we have reached week 10, and week 10 is of graph theory. So when we see that, see this word graph theory, we usually tend to see it like something theory related to graph of a function. So this is what we are seeing till week 9, and in week 10, once you see this term graph theory, you might tend to look this like this, but this is not. So this is nothing related to graphs of a function or graphs of any curves. So what graph theory is basically we are going to study is,
Data structure and
yes.
algorithm.
So in mathematics, how we define a graph is a pictorial representation of any data in an organized manner. So the definition of graph goes like this. So a graph denoted Z is equals to ordered pair V, E. So I will say what V and E are. So this is a graph. This consisting of a non-empty set V of vertices and a set A and a set E. So these are two sets, and these two sets, combining these two sets is our graph. And what are those two sets? One is the non-empty set V, which are vertices, and other is a set E of edges that connects these vertices. So if I want to take an example, suppose there is a graph G, if I say, which is V and E, where V is the set U1, U2, U3, U4. And there is another set, edge set E, which is, so edge set I say E1, E2, E3. So okay, don't worry. Okay, so I have to define another thing. So edge set I am defining as U1, U2, U2, U3.
So,
Sir, can't hear you.
yes, so
Hello?
Yeah.
Am I audible? When did I lose the connection?
Yeah, you lost the connection, sir.
When?
U2, U3, sir.
Acha, V1, V2. Okay. Okay, let me get the co-host access meanwhile. And before that, how many of you have gone through week 10? It's a silly question, I know, but anyway.
So not yet, sir. Not yet.
Not yet, sir.
so I have done. So I have completed
I
the
something
course.
done, sir.
Some. Okay.
So I have completed the CT course. So it's similar to that.
Okay.
In term is similar to both between city and maths.
Right. See, so I guess 80% matches with CT.
Yes, sir. DFS,
Yes.
BFS.
Yeah.
Over there, we only learned depth first year.
Pudistempa.
See, here we will learn in depth. We will see. We see the mathematical side of graph theory here.
Okay.
So we will see different types of graphs: directed, undirected, cyclic, acyclic, connected, disconnected, complete, planar.
Non-linear part.
Yes, so many of this was done in CT.
Oh, these are all done in CT. Okay. After that,
Yes.
what we will see is we will see some algorithms to perform. Algorithms,
Oh, okay.
extra algorithm. So to find the shortest paths. Which
Yes, sir. Sorting, radix sort, double sort.
yeah, topological sorting to perform longest path to. So we will do some calculations. So I haven't shared the screen. So let me get the co-host access, then I will share the screen. Yeah. So almost similar, but we will see some. We will do some calculations in this graph.
Sir, with regards to the calculus part, I mean, will we be visiting the calculus again, or calculus is done for the course, sir?
No, we will revisit it again in the revision session.
No, not that, sir. I mean, will we be proceeding to more advanced calculus like differential equations, or
No. So whatever the calculus you learn, that is up to that
sufficient? Is it?
you will learn here. Later in Max 2, you will see the linear algebra.
Okay.
Okay.
And also, sir, in this last week's assignment, there were very few questions on integral calculus. Was it purposely done, or?
See, even integral calculus was discussed only in one lecture, right? One or two.
Yes, sir.
So, see, we are
Yes, sir.
not
We
that.
had.
We are not that into integral side.
Okay, so this data science and programming requires more of differential calculus. That's what.
Yeah, more of differential calculus, right?
Okay, sir. Okay. Thank you.
So, yeah.
Sir, the deadline for this week assignment is still 9.
No. That will be postponed. That will postpone. You will get an announcement. Don't worry. So this is the only session which will be on week 10 prior quiz 2. So both the sessions of week 10 has been postponed to after quiz 2.
Sir, also the announcement is not there, sir. That
yeah, it will come.
Okay.
Today itself it was.
No, not that.
CT में हो गया सर, लेकिन मैथ्स में अभी तक नहीं हुआ. CT में डेडलाइन एक्सटेंड हो गया.
हो गया क्या? Okay.
Yes.
No,
We
sir,
are
not that as announcement, sir. Regarding the graded assignment, means mock test considering as graded assignment.
I guess you will get it by today afternoon.
Okay,
before
okay,
tomorrow.
okay, sir. Okay, okay.
Yeah, even that is also finalized yesterday only. Okay. Okay. So we will discuss some graph theory again, and we will talk. So see, this is how I define a graph. So graph is a set of vertices and as well as set of edges between vertices. So if I have a vertex set, like let's say u1, u2, u3, u4. So when I say vertices, it is same as saying nodes or points. All are same in graph theory terminology. And similarly for edges, so you can say edges or you can say lines or you can say connections. So whichever term you refer to, that is same in our graph theory. So now see, if I have a test set like this and edge set like this, if we show this in a pictorial way, so if I wanted to show this in a pictorial way, so what I will do is I will draw 4 vertices first, u1, u2, u3 and u4. You can draw anyway. So order doesn't matter here. So you can keep u2 here, u1 here, u4 here, u3 here. Anyway, just draw 4 vertices which are nodes or points. Just plot some 4 points, name it as u1, u2, u3, u4. Now when it comes to edges, so there is u1, u2 refers that there is a line that connects vertex u1 and vertex u2. So u1, u2. I draw a line between these two. So and the next thing is u2, u3. So there is an edge between u2 and u3. And next is u3, u4. So similarly, draw an edge between u3, u4. So this is, if you write it on paper, this is how it will look. If you wanted to show it in a pictorial way, this is how we can show the graph. And I can say this is a graph with 4 vertices and 3 edges. And you might see here edges are not directed. So these are called, if I didn't give any direction to this edge, these are called an undirected graphs. So when I said undirected graph, there is a second one called directed graph. So graphs are of two types. One is directed graph and another one is undirected graph. So what are these directed graphs and undirected graphs? So let's see what is directed graph first. So directed graph means any graph is said to be directed graph if the vertices are connected by edges which are okay, in which the edges have a direction associated to it. So that means, for example, if I wanted to draw a directed graph, so v1, v2, v3. So v1, see this edge. So this particular edge is a directed edge. So v1, from v1, the edge is going towards v2. So this is only one direction. So this is a directed edge like this. So if I have any other edge v2 to v3 and something like v1 to v3. So this graph is a directed graph where each of the edge has a direction associated to it. So this edge is different from, in this directed graphs, this edge is different from this edge. That means the edge going from v1 to v3 is different from edge going from v3 to v1. So this green edge is different from this black edge. between this V1 and V3. So this is directed. What is undirected graph means? It is if no direction is associated to any of the edge, then it is an undirected graph. So the same definition, but here in your edges, all edges have no direction, or I can say all edges are bidirectional. Bidirectional edges means this V1, V2. So this is a bidirectional edge. So I can draw this edge like this, having two arrows both sides, or I can simply draw this line without showing the directions. Okay, so if I wanted to give you examples, see this V1, V2, V3, V4, V5. So a bidirected edge between V1, V5, bidirected edge between V1, V3, bidirected edge between V1, V2, like this. So if every edge in your graph is bidirected, I can simply draw this graph like this. So removing the directions, I can simply draw the edges, lines. So both are same. So even if you can show the both directions, or you can simply remove the directions and say that is an undirected graph. But one caution is, even if one of your edge is only unidirection, if I say, see this particular edge, if this is a directed edge, or it is only directed one side, this particular graph becomes a directed graph. Okay.
Yes, sir.
So even if only one of them is unidirectional.
Even one edge is unidirectional, that whole graph becomes a directed graph.
Okay.
So all your edges should be bidirectional. Then only we can say that is an undirected graph. So that means even this edge should also be bidirectional in order to say that is an undirected graph.
Sir, what happens when every graph is directed and only two nodes are bi-directed? Then what happens?
See, that is what I said. Even if one edge is unidirected, that is a directed graph. So if you say all of your edges are unidirected and only one is bidirected, even in that case also, it is a directed graph. So V1 is directed to V2, directed to V3, directed to V4, but your V1 and V4 are bidirected. You see here this particular edge is only unidirected. So even if you get one edge, even if you can get one edge in your graph which is unidirected or which has only single direction, conclude that is a directed graph. So here you have three unidirected edges. So we need only one, but we got three. Even in that case also it is directed. So at least you have to have one edge which is unidirected, at least. If you find one, then you can conclude that is a directed. So undirected case is only the difficult case. All your edges should be bidirectional. Okay, this is about
Sir, will there be any edge without any direction?
See, without any direction edge is nothing but bidirected edge. See, that is
Okay.
what we have defined, right? So that is how I define. So every edge actually has a direction. Okay. If it is only single directed, that is a directed edge. If it is bidirected, that means even it can go from V1 to V2 or V2 to V1. Then this particular edge, I can simply remove this direction and I can simply draw it as a straight line connecting V1 and V2. And I say this particular edge is an undirected edge. Even this is an undirected. Bidirectional or undirected, both are same.
Okay, sir.
Okay. Okay. So yeah, similarly, we have seen two types of graphs when it comes to with respect to edges. But there are many other types of graphs which are cyclic graph, acyclic graph, connected graph, disconnected graph, complete graph, planar graph. So different types of graphs we have. So each of them have a special property, and if that property is satisfied, that will fall under that particular graph. So if I wanted to see, if I wanted to define what is cyclic graph, so if you find any cycle inside your graph, cycle means, so cycle, what is, I have to define what is a cycle. So
Can we
before,
say it's, is it right to say it's continuous?
Every node is connected to every other node.
no, not like that. A cycle is you start from a vertex,
Not
some
endpoint.
vertex A. So you have to reach back to vertex A by visiting some edges and vertices in between. So I started from A. I have taken one edge. I have moved to some other B, some C, some D, and you can traverse to any number of edges and vertices, but you have to come back to A again. So if you can come back to A again, then that particular path, okay, let me define one by one. So before going to cyclic graph,
Sure. Cyclic graph, we can say it also like a walk.
ah, yeah, cyclic graph is a walk, but not every walk is a yeah, I guess once you are getting, yeah, there is an interconnection. If you can find a walk in your graph, then you can definitely find a cycle in your graph. Okay, path in a graph is, so it's a series of vertices and edges. So V1, E1, V2, E2, V3, E3, V4. So it's a series of vertex, edge, vertex, edge, vertex, edge, like that. So these paths are basically, so even in English meaning, if you see the English meaning of path is just an way, right? You start from a source point, and there is an end point. So you find a path between this starting point and the ending point. You try to find a path. So I travel in this route. Next, I will take a turn to left, and I will travel in that road, and I will take another turning like that. So if I have any graph like this, so let's suppose say these are the junctions in your city. V1 is a one junction, V2 is another junction, and from V2 there are two roads, and there is another junction. Like this. So I am so we are now at V1 junction. So we should reach to V7 junction if you want to go to V7 junction. This is, so which path I should prefer is, so this is what path is. So from V1, I will travel from V1 along with this edge V1, V2. I say this is E1, this is E2, This is just the denotion of edges. That's it. E5, E6. So V1, E1, V2, E3, V3, E4, V5, E6, V7. So this is a path from V1
To
to
V7.
V7. So in graph G, so if I say this is a graph G, this is a graph G, right? There are some 7 vertices and 6 edges. This is a graph with 7 vertices and 6 edges, and all those 6 edges are connected like this. So in this graph, path from one vertex to another vertex is a series of vertex and edges. So V1, E1, V2, E3, V3, E4, V5, E6, V7 is a path. So this is a path. This is a path from V1, V2, V3, V5, V7. Now this is a path. Walk is, so in path, what are the conditions for path is, so once you visit a vertex, you are not allowed to visit the same vertex again. So once you have visited V1, so we are starting from V1, that means you should not come back to V1 again in your path. So all the vertices you visit should be distinct, and all the edges you visit also should be distinct. Okay, both vertex and edges should be distinct in your path. V1, E1, V2. So I shouldn't come back to V2 again. I shouldn't visit E1 again, and I shouldn't visit V1 again. So I should go forward only. So from V2, I am traveling in this path E3 and visiting this V3. Visiting means I am just moving, or I am just going to that V3 vertex, or I'm going to, as we are in junction thing. So I'm going to V3 junction. So once I go to V3 junction, I will not go back to V2 junction again, which I already been from. So I have to go to V7. So coming to V3 and going back to V2 doesn't make any sense. I should go forward. So from V3, I will take E4, and from E4, I will visit V5, and I will go to V7 from using this E6 edge. So this is a path. So an extension version of path is walk, but we don't require walk in our course as of now. But walk is, you can actually revisit your vertices again and again in between. So that means V1, E1, V2, E3. Again I can V3. Again I go back to E3, V2, and I will go to V4, V2, E2, V4, and I will come back E2, V2, V3, E4, V5, E6, V7. So this is a walk. This is a walk from V1 to V7. So look at the difference. So in walk, you can actually go back to the vertices you have already visited, but in path, it is not allowed. Okay. So don't worry about walk, worry about path only. So just understand what a path in a graph means. So what is path from one vertex to another vertex? Okay. So later we will see shortest paths. So here we have only one path. What if we have two paths like this? So there is another edge, E7. So now if you see, if I wanted to reach from V1 to V7, I can go like this: V1, V2, V3, V5, V7. And also there is another path: V1, V2, V3, and from V3 I can go to V6, V5, and V7. Okay, so there can be multiple paths between two vertices. So out of those paths, we will find which one is the shortest path, which one is the longest path. So for that, you need to know what is a path. So this is path, and cycle means So okay, let me define cycle. What is a cycle in a graph? So cycle means if I find a path, or if I find a path from starting vertex, from some vertex u0 to same u0 again. Okay, so observe this. So you are starting from v1 junction and you are traveling around your city, and you can come back to u0 from a path. So when I say path, from another direction. So if you see here, u0, I started from u0, I have traveled to u1, u2, u3, and I have visited many things. As I said, path. So once you are visiting v1, v2, v3, or v4, u4, something, you cannot go back again and visit them. So another path should be there, like this, visiting something, and if I can come back to u0 again, so then this particular cycle u0, u1, u2, u3, and so on, this is un, let's say un, u0. So this particular thing is a cycle. So this is a cycle in a graph, in this particular graph. Okay.
Hello.
Yeah.
Good morning, sir.
Yeah. Good morning.
Sir, I'm sorry, but I joined a little late. So I just lost what you just said about walks and paths.
Okay. See, path is basically, it's a series of vertices and edges we travel. So once you start from v1, so
Okay,
from
sir.
v1 you travel with this edge e1 to v2, and from
Okay,
v2 you travel with this edge e3 and reach v3, and from v3 you travel from with this edge e4, like this. It's a series. Path is a series of vertices and edges
Okay, sir.
simultaneously, and a condition for path is no repeated vertices and edges. So once
Okay,
you
so
have visited E1, you are not allowed to come back to E1 again. Similarly for vertices also, you cannot repeat vertices or edges in your path.
okay, sir. So if I go from V1 to V2 through edge E1,
Hmm.
so I cannot travel back from V2 to V1 through edge E1.
Yeah, to edge E1. So if
Okay.
it has to be a path, so that
So it
that will
is.
not be a path.
So sir, it is directional.
See, these are see, this is anyway bidirectional. So an
So
undirected edge is nothing but a bidirectional edge.
okay, sir. So simply it means if once even edge is travel, we cannot go through once, even if we want to go back.
No, then that will fail the property of path. So that will not be a path from one vertex to another vertex.
Yes, sir, but we cannot go through edge even again, na?
You can go. See, that is not a restriction. But for definition of path, see, you can go. If you go back, then that will become a walk.
Okay, sir.
Okay. So you can V1, E1, V2, again E1, V1, again V1, E1, V2. Then you see V2, E3, V4, V3, E4, V5, E6, V7. That will become a walk from V1 to V7. That is not a path. So if you didn't repeat edges and vertices in your series, so I will say this is a series of vertices and edges. In this particular series, if there is no repetition of vertex and edges,
Okay, sir.
then that will be a path.
Okay.
So actually path and walks are between two vertices. Okay. So I have to reach from one vertex to another vertex, or I have to find a path from one vertex to another vertex. I'm trying to find a path from V1 to V7. When I say path,
Yes,
So
sir.
from V1 to V7, I should travel between edges and vertices and reach V7. But when I travel, I am not allowed to repeat my vertices and edges. I am not
Okay, sir.
allowed
Okay,
in
sir.
order to be a path.
And then if we travel again to particular edges and vertices, it becomes a walk.
It becomes a walk.
Okay, sir.
Right.
So it is actually two different types of ways to travel to vertices and edges.
Yeah, right.
Oh, okay, sir. Thank you.
So yeah, even path is a walk. Okay. Even
Oh,
path is a walk. But in this walk, we are not repeating edges and vertices. So we separate that as a separate kind and we will say it as a path.
okay, sir. So
Got it?
actually, the path is subset of walk.
Yeah, subset of walk. So you can see it from
Yes, sir. These
here
are,
also.
yes, sir. Two.
Right?
Okay, sir.
So every path is a walk. Not every walk is a path.
Okay, sir.
So regarding cycle,
Hmm.
there must be only one repeated vertex, right?
Yeah, in this cycle, see, if you are repeating another vertex, that means even that smaller will be a cycle.
Okay.
So let's
And
say
what about the minimum number of required nodes to have the
vertex.
shortest cycle possible? Can it be one?
Three vertex, right?
Three.
Vertex. Yeah.
Okay, got it.
Sir, so two vertices will never make a cycle?
Two vertices, see, that is an debatable thing. So usually we don't consider them as a cycle.
Okay.
Okay.
And sir, so cycle is also not a path, right? Because we're repeating the vertex.
Yeah, cycle is not a path. Cycle is, that is why these are terms. See, understand the terms of graph theory. Okay, these are all we define something and we will give a name to it. So this is a cycle. So we say this is a cycle. This is different from path. Path, walk, cycle, and what else? And again we will see connected, disconnected. So these are all terms of graph theory. Okay, be used to it. These terms.
Yes.
Sir, repeating edges are allowed in cycle?
See, think it logically. Okay. So if you are repeating a vertex in your cycle, so let's say here u2 is repeated again. Now you see this particular thing u2 to u2 is a smaller cycle, right? So u2 u3, this is a path in between and you are reaching u2 again. So that means from u2 I started and I am ending with u2. So this will make a smaller cycle inside a bigger cycle. Okay, let me see. Let me give you an example. So this time 1, 2, 3, 4, 5, and 6. So I add an edge between 1 and 2, 2, 3. Okay. Now you see. So if I am starting from vertex 1 and I wanted to find a cycle, whether this has a cycle or not in this graph. So I start with 1, I reach 2, I reach 3, I reach 4, I reach 5. This should be a path initial. If you are coming back to 3 again and going to 6, going to 1. Now this there is a path. This is a path from 1, starting from 1 and ending at 1. So this is not a path actually, but there is a cycle. So I am traveling between vertices, and in between if you see I am repeating an vertex 3 and 3. Now 3 and 3 are being repeated. If you see, if you exclude this particular thing, left of this and right of this, even this 3, 4, 5, 3 is a cycle. if you correctly observe. So
Sir, if we go like sir 1 to 2, then 2 to 3, 3, 4, and 4 to 5, and again from 5 to 4 and 4 to 3, then 3 to 6 and 6 to 1, then it is a cycle.
So
Sir,
see,
we
that
are
is
repeating this H 5 to 4 and 4 to 3 again, and then from 3 to 6.
see, these kinds are not allowed. That is what I said. So when I am talking about path, that means it should be a path. Okay.
So sir, this is not cycle.
So this is not a cycle. So whatever you said is not a cycle. 1, 2, 3, 3 to 4, 4 to 5, 5 to 4, 4 to 3. This is what you said, right? This is 3 to 6, 6 to 1. So
Yes.
this is not a cycle. This is not referred to as a cycle. So cycle definition is you try to find a path starting from one vertex. You try to find a path that again reaches to that vertex. So if you can see, look it like a cycle. Okay, you start from here. How we draw a cycle? You start from one point, you draw a round circle, and you reach that point again. So this is how cycle. So the same thing goes in graph theory also. You start from a vertex and you try to find a path, and if you can come back to u0 using that path, then that will be a cycle. So when you draw a circle also, if you see, when you draw a circle, you don't draw half and you go back and you draw it again completely. No, right?
Yes, sir. Thank you.
You don't go back, right? So that is how it should work.
Should it be walk, sir?
Hmm?
What you say about it should be walk?
Yeah, it will become walk, and cycle is not defined on walk. Cycle is defined in terms of path. Okay. So this is not a cycle. This is not referred to a cycle, but this is a cycle.
Cycle something like closed graph something.
Closed path.
In this, there are two cyclic paths.
Yeah, in this there are two cycles. This is one cycle. This is another cycle. So cycle is very simple.
Yes,
You
sir.
start from one vertex, you reach all other edges and vertices without repeating. And if you can come back to that particular vertex again, any vertex, you choose any vertex. If you can come back to that vertex again, then there exists a cycle in your graph. So you start from 6. So if you start from 6, you go to 1, 1 to 2, 2 to 3, again 3 to 6, I can come back. So starting from 6 and I can come back to 6 again using some edges and vertices which are not being repeated again. So that means I have a cycle. So this is referred to as a cycle. So if I have a cycle in my graph, if I have a smaller cycle also in my graph, then that graph is called as a cyclic graph. So if I can find a cycle in my graph, that is called a cyclic graph. So
Okay,
cyclic
sir.
graph means there exists. So this is the denotion of there exists. This is a symbol of there exists. Okay, there exists a cycle in graph. So if there exists a cycle in graph G, then that particular graph G is called cyclic graph. Okay, that means if you can find a cycle from starting from one vertex, and if you can trace back to the same vertex again in one big graph G, a big graph G is given to you. If you can find some vertices such that, so there is a cycle inside those vertices itself. There is some subpart of that graph where you can actually see a cycle. Then if you have a cycle like that, that particular whole graph G is called as a cyclic graph. So even here, if you see an example,
Sir, minimum one cyclic path is exist.
Minimum one. So this is a big graph. So this is not even a big graph. See, even for n is equals to 10, that means if you have 10 vertices and some edges between them, is a very small graph, considered as a small graph. Okay, now V8 to V2, let's say from V6 to, okay. Okay, so this is a graph with some 8 vertices and some 1, 2, 3, 4, 5, 6, 7, 8. So 8 vertices and 8 edges. This is a graph with 8 vertex and 8 edges. Now see, if I start from V1, so V1, if I start from V1, I can go to V2, but there is only one edge connecting to V1. So I cannot come back to V1. So if I have to come back to V1, I should actually use this edge only. So there is no other edge that comes back to V1. So with respect to V1, I cannot find a cycle. When it comes to V2, so even for V2, from V2 to V3, I can go. From V3 to V4, I can go. But V4 is a dead end. I cannot come back again. Similarly, from V2, I can go to V5. I cannot come back. Same thing. V2 to V1, I can go. I can come back to V2 again, but that is not referred to as a cycle. So even if you see here from V2 point of view, you cannot find a cycle. Similarly for V5, V3, V4 also. But when it comes to V7 or V6 or V8, so if you see here from V7, so V7, I can go to V8. Okay, this is edge E1, E2, E3. So from V7, I can use E1 edge and I can go to V8. And from V8, I can use E2 edge. I can go to V6. And from V6, there is a different edge that goes back to V7 again. So that is E3 and V7. So if you look at here, I started from V7. I traversed from E2, E1, E2, E3, visiting V8, V6 vertices, and I am actually coming back to V7 again. So that means there is a cycle inside my graph. This is a cycle. V7, V8, V6, V7 is a cycle, or V8, V6, V7, V8 is a cycle. Okay, in this big graph, so this is the graph G. So this graph G, out of this graph G, I can actually find a smaller part where actually there is a cycle. So there is a cycle inside my graph G. So what I conclude is this whole graph G is cyclic graph. So this G is a cyclic graph.
So, since there's no direction in this graph, we can go both anti-clockwise and clockwise, right?
Right.
Okay, so must we mention it?
Must be?
Must we mention like which direction?
No. See, it's not. If it is an undirected graph, you can actually go from V7, V6, V8, V7.
Okay.
You can do that thing also.
No,
That
like in the question where we have to identify whether we're going clockwise or.
In the question? No. There is no questions like that. So it is not important also. See, that doesn't matter. We are actually trying to see whether there is a cycle or not. See, in which direction the cycle is not required.
Okay.
If there is a cycle, we conclude if even if a small part you can find a cycle, the whole graph will become a cyclic graph.
Okay.
Now that we have seen what is cyclic graph means, so a cyclic graph is quite opposite to that. So you should not contain any cycle in your graph. So now
But sir, in cyclic graph, there is a direction in the
Sir, hello.
page.
Sir,
Direction is important. No?
hello.
Mm-hmm.
I'm audible.
Yeah, you are audible.
Sir, direction is non-matter for that is called cyclic or not not cyclic.
In undirected graph. See, as of now, today I am going to discuss most on undirected graph. So that will be easier to interpret. Okay. So I'm not much interested to involve directions between edges. So in the undirected graphs or bidirected, this is nothing but the bidirected graphs. Now tell me, Kamal.
Sir, only one cycle must be there. Then only we can call the complete graph as a cyclic, right?
No, at least one cycle.
At least, sir. At least one cycle. Yes.
Even if you find one cycle, that is enough. You directly conclude that graph is a cyclic graph. You don't worry about other cycles. No need to worry about other cycles. One cycle is enough. So even there is an edge in between these two. Even if you find a cycle here, that is enough. Even this is also a cycle, but this is enough to conclude it is a cyclic graph. Okay. A cyclic graph can contain more than one cycles also. That is what I meant. Okay. Yeah, Kamal, you are asking something. Okay, someone is asking something regarding directions.
My question is simple, and direction is non-matter for the non-matter. For this is called cyclic or not cyclic.
As long as we are dealing with undirected graphs.
Yeah.
Okay. When we go to direction, there is an extra concern or we have to be sure in direction perspective. So even direction comes into the play. Okay. Someone is asking regarding directions.
Yes, sir. I'm asking.
Yeah.
Sir, it's clear, sir. Now you asked about the undirected.
Yeah. So in undirected graphs, whichever direction you follow, if you find a cycle, that is referred to as a cycle. And we say that is a cyclic graph. A cyclic graph means you should not contain any
cycle.
Yeah. Does not contain any cycle. So your graph, even your subpart or at any node, 3 vertices should form a cycle in your graph. Okay. So for example, you see here, there are some vertices. I don't really. So there are some 5 vertices. So inverted sigma. So if a graph is given like this, let me draw like this. So summation symbol. If I have given you a graph like this, now you can see you cannot find, you start from one vertex, you start from this vertex, you travel between edges and vertices, but you cannot come back to that vertex again. So whatever the path you choose, you cannot come back to this vertex again. Even for this vertex also, even for this vertex also, even for this vertex also, and the same thing goes here, even for this vertex. So whatever the vertex I choose, I cannot come back to the vertex again by traversing between some edges and vertices. So in this graph, I cannot actually find any cycle. So this particular graph is called as a cyclic graph. So there is no cycle inside my graph.
Sir, so until we make it this particular path have walk, it will be a acyclic graph. We cannot walk back again in this acyclic graph.
Yeah. So simple. Acyclic. Now let's come to connected, disconnected. So these are all opposite
Excuse
terms.
me, sir. Sir, I have a particular question. What is the significance of a cyclic graph? What does a cyclic graph signifies? If we found a cycle within a graph, what what meaning does it carry? So,
See that carries. See, when it comes to application parts, these graphs are actually drawn from a data. Right?
Okay, sir.
From that data, what we are doing is we wanted to see that data in a pictorial way. If you wanted to see that particular data in a pictorial way, we then bring this graph theory, graph things, and we will refer vertices as some data. We will refer edges between vertices as some other column or data, and then we will look at the data in detail. So while you are doing that, when you have a cycle inside that, so let's say, let me give you an example. Here itself, if I
Sir,
have
airline example professor said in lecture.
yeah,
Sir,
airlines
can you
example you
clear,
can see.
going from Jaipur to Delhi, Delhi to Lucknow, and back to Jaipur.
Yeah. Yeah, even that thing, or in a very simpler case, I wanted to take. See, in a class there are 5 students. So I have this data. In a class there are 5 students, and the thing is, I just wanted to elect one student such that that student is superior to the other 4 students. Superior, or maybe I
Most
just wanted
popular.
to pick the topper kind of thing. I just wanted to pick the topper kind of thing. And each of the vertices represents each student, and the edge between, okay, edge, now this should be directed edges. Directed because direction shows one student is superior to the other student. So if this particular edge denotes that this particular student is superior to this particular student, or this particular student got more marks than this particular student. So what if 3 students got equal marks like this? So he is superior to this guy, as well as this guy is superior to that guy. Similarly, like this. So now you see, now we are in a difficult condition. You cannot conclude which guy to be chosen as the superior person because you had a cycle here, right?
Yeah.
So that means if you have a cycle inside any graph, when you convert the data to the graph theory, if you have a cycle inside this, most of the cases, what happens is you cannot conclude anything from by converting the data to the graph theory, graph thing. So most of the cases, it will happen. It will happen that if you found a cycle inside any graph, then that particular graph ultimately to find the shortest paths, or when you perform algorithms in week 11, you actually look at whether there exists a cycle or not. If there is a cycle, you are done and dusted there itself. You cannot find the shortest path. Okay, so there are many applications. So once you find a cycle, actually then you will be depressed a lot by converting your data into this graph thing. So first and foremost thing what we look into is whether I shouldn't contain any cycles in my graph. Then only I can perform. See, that is where this directed acyclic DAGs comes into play. So in most of the scenarios in real life also, we actually, whatever the data we get, that will actually be directed acyclic graphs on. So when I say directed acyclic graphs, in order to understand acyclic directed things, you definitely need to understand what is cyclic, undirected, all these things. Okay.
So DAG means directed acyclic graph.
Yeah, DAGs means directed acyclic graphs. Have we come across in week 10? I guess yes.
Yes.
Okay, we will see that thing if time. So these are, see, application part, don't worry about anything as of now. When it comes to week 11, you will understand why we have studied week 10 particularly.
Okay, sir.
Yeah. So this is acyclic graph. Acyclic graph means you shouldn't contain any cycles in your graph. Okay. So connected and disconnected are very easy to see. So connected means if there is a path between any two vertices in your graph, in graph G, then G is connected. Then we say G is connected graph. Okay. If I can find a path between any two vertices, I choose randomly two vertices, and if I can find a path between those two vertices, similarly any two. So any two, all two vertices between any two vertices, if there is a path, then that particular graph is called a connected graph. So for example, see, this is a graph. This is a graph, and this graph is a cyclic graph. You can see here. So there is a cycle. So this is not an acyclic graph. So now see, if I wanted to find so if I choose any two vertices, whether it can be 2, 6 or 4, 5 or 1, 3 or 2, 5 or 1, 1, 6 like this. So you choose any two vertices, I can actually find a path between those two vertices, right? If I choose 1, 6, so this will be a path. 1, 2, 2, 5. 5, 6 is a path between 1 and 6. Similarly, if I choose 4, 3, so 4 to 2, 2 to 3, 2 to 5, 5 to 3 is a path between 4 and 6, 4 and 3. So similarly, 2 and 6. So 2 and 6, there is a path 2 to 5 and 5 to 6. So like this, if you choose any two vertices in your graph G, so if you can find a path between those two vertices, then that graph is called as a connected graph. But if you have picture with you, it is very easy to see whether it is connected or not. So if your graph graph is not breaked, or if you can see two different graphs in the same graph, then that is a disconnected graph. If you see if you see a graph like this, there is no disconnection between vertices. So all these vertices are connected anyway, in some way, right? If you see graph like this, so this if you see like this, so this is the whole graph G. But if you can see inside deeply, you can see two different graphs. Actually, this graph is breaked into two different graphs. So this is one graph and this is another graph, subgraphs I say. So this is a smaller graph and this is a smaller graph, and there is no interconnection between these two graphs. There is no connection, or there is no edge connecting between these two subgraphs. So these type of graphs are called disconnected graphs, where you can actually find two vertices. You can actually find two vertices. Let's say UV there exists. So I actually defined this thing, right? There exists two vertices UV such that there is no path between U and V. No path between U and V. So I say this is U, this is V. I cannot actually find a path that starts from U and ends at V, because there is an breakage. So vertex U is in this component, so we call these as components. These are all terms, and I don't see whether professor mentioned anything regarding component. No, right? Components of a graph. Okay, don't worry about components and everything. So this is in this particular graph G, you cannot actually find a path from U to V, right? If you start from U, I go to this, and I cannot actually go from this to this. There is no edge connecting between these two. So these type of graphs are called disconnected graphs. So graphs where if I find two vertices, if there is no path between those two vertices, then that is called as disconnected graphs. Connected, disconnected, cyclic, acyclic, and there are complete planar. So complete graph is basically you simply join every vertex to every other vertex. Okay. So complete graph. See, these are all some properties. So if they satisfy one property, those graphs fall into one category. So these graphs are actually falls into the property that every vertex is connected to every other vertex in the given graph. So if I have 4 vertices, so each of this particular first vertex is connected to every other vertex like this. And this particular vertex is actually connected to one already. So this and this. And the third vertex is also connected to every other vertex. And the fourth vertex is also connected to every other vertex. So if you find a graph where each of the vertex is connected to every other vertex in the graph, then that particular graphs are falls into a complete graph kind of thing. So these are called complete graph. And one property of complete graph is if you have n vertices in G, and if G is complete graph, then the number of edges. So this is also the notion of number of, okay, number of edges in G will be
n into n minus 1 by 2.
Right. So you can actually plug in n is equals to 4 and you can actually get number of edges as 6. So similarly, even if it works for any n. Okay, this is complete graph.
Sir, here that n will be the number of edges, right? Not the nodes.
N will be number of vertices.
1, 2, 3, 4.
Yeah, these are vertices, nodes, or points. Okay, these things 1, 2, 3, 4. So n will be 4 in this case. If you substitute n is equals to 4, you can actually get number of edges, which is E. So you can actually get E as cardinality of E. So cardinality of E means number of edges as n into n minus 1 by 2, which is 6. Which will be 6 for n is equals to 4. Okay. So these are
Sir, how many cycle in complete
how
graph?
many?
How many cycles in complete graph?
n into n minus 1.
Sir, these are edges. Okay, n into n minus 1 divided
I'm
by...
saying about cycle.
Cycles, yeah, I got you. See, you can actually prove. You can actually derive. Right? So you start from one vertex. Number of possible cycles will be?
There is any formula?
2. I guess there will be. I hope so. As of now, no one discovered or... See, this is the first time I am hearing at least a number of cycles in complete graph. Okay.
Length will be same for all cycle.
Length will be same for all cycles.
If they
Length of cycle is different.
say that distance will be same for all.
See, 1, 2, 4, 1 is a cycle. Right?
No.
1, 2, 3, 4, 1 is a cycle. but the distance are
Different, sir, different. It will be different.
different. Yeah, actually this is a good thing to do. I don't know, no one. See, we start from simple case. So if you wanted to prove something in mathematics, a mathematical induction is best way to prove. Okay, base case, consider base case and you get
Worst case.
base case, not the worst case. Okay. So it is called as base case. Base case means the very starting case.
Yes,
So
consider
now,
best case.
Yes.
so you see, this is only one cycle inside this triangle, right? Let me say C is the number of cycles. So for n is equals to 3, yeah. So which is the base case, we have a number of cycles as 1. If you say true, okay, mathematical induction requires, okay, for, let's say there are n vertices, which is complete. So when I choose one vertex, 1, 2, n is a cycle, 1, 2, 3, n is a cycle, right? Like 1 to n, likewise I have 1, 3n, like this. So in between, like this, 1, n minus 1, n is a cycle. Okay, now 1, 2, 3 is a, okay, n1. Okay, lastly, you add 1. So 1, 2, 3, 1 is a cycle. Can I find anything? Okay, if I wanted to have a cycle of length 3, 1, I, j, 1. So where this I and j can take values from 2, 3 and so on. This is n minus 1 till n minus 1. This starts from 3. Even in this case, this is lot, man. You will get a bigger value.
Yes, sir.
Okay. So you try to find. So
Yes, sir.
you try to get this. So start from one vertex. Try to find number of cycles that start
सर
from that
कुछ तो
vertex.
कंडीशन दिया हुआ रहेगा तभी पूछेगा ना. ऐसे तो डायरेक्ट नहीं पूछ सकता.
And thanks for giving this idea. Maybe end term में मैं पूछ सकता हूँ.
हाँ तो ड्रा करके हो जाएगा. और
हाँ, ड्रा करके मतलब n is equals to 10 दूंगा मैं. How is that? ड्रा करोगे?
हो जाएगा.
हो जाएगा. You will get only 1 hour.
Nothing is impossible.
Yeah, nothing is impossible, but managing time is
very much.
So there is a formula to find how many cycles in the graph.
सर तो फॉर्मूला कितना याद रखेंगे?
Formula? What is the formula?
Sir, I'm asking from
You are asking. See, if I know the formula, I have given you directly, right? Even the very first time I listened this number of cycles in a complete graph.
At the beginning, you mentioned that.
I find there is a 4 cycle in the given graph. You given in the 1, 2, 3, 4. So 1, 2, 4, 1, 2, 3, 4, 1, 2, 3, 1, and 1, 3, 4, 1. There is a 4 cycle.
Yeah, 4 cycles possible for 1, right?
Yes, sir.
1, 2, 4, 1, 3, 4. See, I started like this only. 1, 2, 3, 4. 1, 3, 2, 4. Okay, what else? That's it, 4 cycles, huh?
4 cycles.
Yeah.
From
4
starting
cycles.
from 1.
That is starting from 2 you will get 4 cycles. From 3 you will
So
get 4
probably we
cycles.
have to use permutation and combination.
Sir, can we do this like NC3 plus NC4 dash 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 NCN minus 1 plus NCN, sir, and all this sum will give number of cycle.
NC
3, 2 NCN and adding all these.
Okay, just tell me with respect to n is equals to 4, what is?
Yes, sir. So NC3 gives all the all the cycles with 3 vertices. Then NC4, sir, here, yes, plus NC4, yes, sir, 4C4. So, sir.
Okay,
Sir,
but
Within that also the order would matter.
See, for when you say 4C3, here itself I got 4 cycles.
Yes, sir. And 4C4 1.
4C4 1.
Yes,
Okay,
sir.
I'm
I
only
got the
getting
number
5
of
cycles.
cycles. Yes, sir.
But in this graph, I guess it is 16 cycles.
No, sir. Only 5, sir. 5 distinct cycle here.
In this?
Yes, sir. 5 distinct cycle.
Okay, what
Sir,
is 2, 4, 1, 2? That is also a distinct cycle, right? 2,
yes,
4,
sir.
1, 2. Okay, 2, 3, 1, 2. See, when
Sir,
you start
here,
from one vertex, if you are going to get 4 cycles, then that will repeat for every other vertex also.
So it is 4 for 16 cycles.
16 cycles. So
n square, sir.
n square.
Yes, sir.
If you are claiming n square, when it comes to 3, it is only
For
1.
best case.
I think
So
that
when n is equals to
like
3,
when it
Now
even
it changes for every single
it
number
will
of
change. Sir, it will
vertex
change.
in
Minimum
graph
it will change, sir. It will be really difficult to identify because minimum 3 nodes are required to bring a cycle, and maximum also it can happen. Like it can be also 10 nodes to connect if they all are connected. So really difficult to find it out here. How
It
many
needs to
nodes is
change
connected?
for
Minimum
every node added.
It need more data to.
yes, and minimum connection 3 nodes are required, and maximum can be any number
Oh,
of
we can
nodes.
start with 5 nodes, 5 vertices, and then see how much it changes from having 4 vertices of complete graph of 4 vertices and having a complete
just a
graph of
second,
5
I can
vertices.
actually think
Only
of now itself. See, number of 3 cycles starting from 1. How many number of 3 cycles will be? So I have to choose 3 vertices. So 1
Yes, minimum
and other 2 vertices I can choose from any of the n minus 1 vertices, right? If I use permutation and combinations here, so I have n minus 1 chances to choose one vertex, and once I choose this particular vertex, I will have n minus 2 chances for the third vertex to be chosen.
Yes, sir. Yes, sir.
So there will be n minus 1 into n minus 2 ways
Then
I
in the
have 3 cycles. 3 cycles.
Sir,
So in the above graph, is it possible to go 1, 2, 4, 1 or 1, 4, 2, 1? So this is another cycle, or is it's called a reverse?
sir, because direction matters in particular
That is
cycles.
also one more cycle.
So 1, 2, 4, 1 or
This is not
1, 4,
16.
2, 1.
Yeah, 1, 4, 2, 1 is also a possible cycle.
So 1, 2, 4, 1 is
So there
different
is a
from 1, 4, 2, 1.
Yeah. 1, 4, 2, 1 is possible. 1, 4, 3, 2 is possible. Sorry, 1, 4, 3,
whole
1.
thing 1 2 3 4 1.
Actually, 1, 4, 2, 1 is different from 1, 2, 4, 1, na?
1, 2, 4, 1 is different from 1, 4, 2, 1. Correct.
yes. So there is an all 16
There is
into
a total
16
5,
plus
sir.
16,
Mm-hmm.
32.
For 1 there is a 5 cycle.
For 1?
There is a 5 cycle. One is 1 2 4, then 1 4 3, then whole thing, or then 1 3 4, then 1 2 3 5.
1, 2, 4, 3. Yeah, correct. 1. See, that is what I am counting now. So in this counting, you will not miss anything. So what
So
I do
surely
is,
you do not give in the final exam for that type of how many cycles.
surely.
You did not give any type of question. कि how many cycle in the graph.
I will
If n,
definitely give. Why I will waste this much of time then? I'm thinking.
Sir, if you
Thank you,
give,
sir.
then give us a formula, please.
Yeah, I will see. I will give if I think you people will solve it only. Okay, it's not like they do.
सर इसको लास्ट में देखेंगे
Last
टाइम
में
मिलेगा तो
Right, sir.
Okay, I will definitely come up with the formula.
So do we need to know the cycles part?
Not much. See, you just understand what is cyclic graph. For understanding cyclic
Okay.
graph, you should understand what is a cycle. So once
Okay,
you
sir.
understand cyclic graph, then you will understand what is acyclic graph.
So as a number of cycles, do we need to know how to calculate?
As till today, no. Till yesterday, no. From today, might be yes. Okay. See,
This is
don't
not
worry. If that is not important, we will not give. I'm just
okay, sir.
interested to find. That's it.
Okay.
We will do this later. We will
So,
keep this
so is
later.
it never discovered how many cycles can be there in a complete graph of n vertices?
Sir, if you consider, sir, one,
Sir, I have to leave, sir.
four, two,
Yeah, sure.
और फैक्टोरियल हो सकता है क्या सर? अगर 3 है तो 3 फैक्टोरियल हो जाएगा, मतलब कि 6 साइकिल बनेंगे.
Okay. 3 है तो 3 factorial है क्या?
Yeah.
Sir will discuss some the rest of the topics.
We will discuss the rest of the topics first, and we will come back to this. Okay. Till now we have seen connected, disconnected, complete. Yeah, complete graphs. Okay. So these are some types of graphs, and till now we have seen how to pictorially see a graph. From now there is another representation which is called as adjacency matrix.
So graph coloring.
Yeah. We will come to that. So after this I will come to vertex coloring.
Okay.
Adjacency matrix.
So there is a answer over math stack exchange over number of cycles in a complete graph.
What is that?
So excuse me, if it says there is a graph with n vertices, suppose that it is a symmetric group, X is a complete graph. By permutating its vertices, it is clear that you can send any n cycles to any other n cycle vi action. So we can say that skx transitively on the n cycles. So it is saying in Hamilton graph, but
Hamilton. Okay. Okay. Then it is much advanced.
Yes, sir. The orbit stabilizer theorem states
Okay.
that the
Okay. Don't worry. So then I will not be asking this question.
So and then it says we can compute the sum for k, a value k from going from I equals 3, because I has only one cycle. So starting from I equals 3, the answer would be permutation factorial of k divided by k minus I factorial multiplied by 2i. So k minus I factorial into 2i is in denominator and k factorial is in numerator.
Got it.
And there is a summation from I equals 3 to k.
Okay. Yeah, they are actually doing summation of 3 cycles, 4 cycles, 5 cycles, 6 cycles to n cycles.
Yes, sir.
Okay. So this is much advanced graph theory which we are not going to study at all.
Yes, sir, because I was just searching, it was saying Hamilton graph, so I just searched for complete cycles. So it opened a math.stack exchange.
Yeah, math.stack exchange is a good website. You can actually find anything. Okay. So yeah, don't worry about that.
Thank you, sir.
Sir, so what is the deadline for this week assignment? Are we
Weekend assignment will be after quiz 2. It will be postponed to after quiz 2.
Sir, can we discuss graded assignment question for 8th one?
For ninth week?
Ninth
Or,
week.
yes, sir. Last week graded assignment, I have a doubt.
Question number?
1 second. It's question number 8, sir.
8. I have given marks for x is equals to 10 also, minus 10 also.
No, not x equal to 10, but
Okay.
I have the procedure point.
Okay. Okay. Just give me 5 minutes. Okay. Other people.
Okay, sir. No.
Discuss. No. I will discuss that thing. Yeah. What is the question?
F of x is equal to minus 5x plus 1.
Then
x is in interval 0 to 10. And x square if x greater than 10 and less than or equal to 20. You have to find global minimum of 0 to 20 both in GB.
Is included.
Actually, the question should be global minimum value. Value of f. So as we missed value here, so we have given marks for x is equals to 10 also. Those who are worrying.
Yes, I am.
What is your doubt?
Sir, how to proceed, sir, like for this problem?
You can actually draw the graph, right? So let's say this is 10 and this is 20. So from 10 to 20 it is x square, right? So 10 square is 100. So let's say this is 100 and it should be open. 10 is not included in this. So it will go till 400 like this. Right? And till 10 it is minus 5x plus 1. So if I try to draw the plot of minus 5x plus 1 is a straight line.
Yes, sir.
Straight line with slope minus 5 and intercept is at 1.
Slope is 5 or minus 4?
Slope is minus 5. So intercept is 1 by 5. It will be like this. One and 1 by 5. So somewhat like this and closed here. Closed at
minus 49.
Okay. Yeah. So okay, this is not there. My interval is from 0 to 100. This is 1. So this is my graph finally.
Yes.
So this is my f of x. So what is the global minimum? Where the
graph is least.
Contains the minimum value, right? So if you see in this graph, the minimum value is attained at this point.
Sir, but according to whenever we meet a break point, we should check by the definition if it is less than or 10 and greater than 10, two different values are there. How can this be the minimum value?
You can check na. See, you take the left side points.
Yes, sir.
So whatever the point you take to the left of this point, so those corresponding values are greater than this point, right? So I say, let's say this is f of a. And whatever the left points I take, x minus, f of x minus will always be greater than f of a.
Yes, sir.
Even if I consider the right side points are actually positive values.
Okay.
So
Yeah,
this
sir.
will also be greater than f of a.
Sir, can we do this by second derivative method? Can we do this by second derivative method?
See, actually it is not differentiable at that point, right?
Yes.
How can we find f dash of anything?
Sir, but when it is not differentiable, how are we defining maximum and minimum there? I have not
See,
understood.
that is what critical, when we discuss these critical points, Critical points are basically points where f dash of a is 0 or at points f is not differentiable. Once you know the critical points, and local minima and local maximas are defined on critical points.
Okay, sir. I got confused, sir. Thank you, sir.
Okay, so in this around this smaller interval, whatever the point I take left side or the right side, function values are greater than that point. So
Yes,
around
sir.
this point, this particular value x is equals to 10 or f of 10 takes the minimum value.
I confused myself with negative side of values. I thought above that they're less than and these are greater than. So I thought it is not a point. Thank you, sir.
Okay. So this is it. So anyway, we added that answer also. Actually, we have given answer as minus 49 for this, as this is an. So
Yes, sir.
Sir,
Yes.
can we modify? Sir, can we modify a little bit in this question, sir? For example, 0. If we take 0 to 20 and 20 to 30, or 20 to 40, sir. In that case, how the graph will be, sir, and what will be the minima and maximum?
0 to 20 and 20 to 40, is it?
Yeah.
The same, it will be same.
Minus 99.
So the graph will be same. So till 20 it will be like this, and from 20 it will be like this. Now the global minimum attains at, so it should
20.
be termed like this: global minimum attains at x is equals to 20, and the global minimum value is minus 99. So global minimum value or the function value at the global minimum, these are all refers to y coordinate of your or f of x value. The global minimum or local minimum, when I say only global minimum or local minimum, attains at some point. So that will be referred to as x coordinate.
Sir, global maximum इसमें कितना होगा?
Global maximum is infinite.
There would be no global maximum, no, sir?
See, if it is restricted to particular interval, you see at x is equals to 40, it attains the global maximum.
Yes.
Okay, we are restricting the graph.
But sir, there isn't any critical point, so we can't say that the point is a global maximum.
This comes under boundary point, right?
Yes, sir.
Now boundary points also we defined separately for boundary points.
Yeah, we can say that this is the maximum of graph, but we cannot say the global maximum of this graph or this function.
No.
We can actually say, I guess. Have I said we cannot?
Sorry, sir, could you be please some loud? I can't hear you.
No. Have I said? Have anyone?
No,
of us
sir, you
said,
have not said that. No,
okay.
you considered boundary points even in a local minima, global minima.
Yeah.
But you said you can't decide whether it's a critical point, but
point
we can
or not.
definitely
Yeah.
find out whether
That
it's
is what-
maximum or not.
See, this doesn't come under critical point. This is a boundary point, but this counts as a local minimum or local maximum.
So
just go back to the
is there
session.
will be a
Sir,
solution rolled out for week 9 graded assignment?
I didn't understand.
So a solution, complete solution where we have answers of every week's graded assignment.
Is it not given?
That's given in the
Resource from instructors.
yes, sir.
Okay,
Yes,
sir.
sir.
Okay, sir.
Sir, I have a question. In this particular question, you've given marks for even x is equal to for 10 as well as minus 49.
Minus
But then
49.
Yeah. So in an exam, how do we decide? Are we supposed to give the x value or are we supposed to give the fx value?
See, that is what I said. There should be in that question, question number 8 in your graded, we should have given you global minimum value. So this is missed.
Right.
Okay.
Okay.
That
So
is
if
why
we
have,
if you have written value, then we have to give fx. If you say where is the global minimum, then we have to give the value of x at which the
X.
global minimum is
Yeah.
achieved.
Yes, right. So we will specifically mention in the end term. So this is not in the syllabus for quiz 2, so don't worry about that. But in end term, we will specifically mention whether we are going to ask the value of the global minimum or the point at which the global minimum attains. We will clearly mention.
Excuse me, sir.
So,
Are we done with this question?
Yeah, we are done with this question.
Sorry to interrupt, but can you please explain the meaning of 7th question?
Yes, sir. I want.
Yes, sir. I just wanted to ask this question, sir. How to solve with the Riemann sum, sir?
Sir, in this question, you will consider for graded assignment, like that they are considering the y value, I think, in graded assignment.
See, we are considering y value as well as we have given marks for x. Those who have given x value.
Okay. Okay. Sorry, I have not seen it.
So yeah, graded
Sir,
assignment number 7.
Graded assignment 9, question number 7. Please explain the meaning of question. I don't get the question exactly.
Okay. Let me see.
We have to solve by Riemann sum, sir, right?
Okay, so f of x is equals to 18x square plus 4 by 6. Am I correct? Is this the question?
So I have another question. Can I say my question?
Is it okay?
I think there is a different question for everyone.
Okay.
So the question is, let f of x equals to 37x square plus 19 by 6, where x is an interval 0 to 6. The estimated area obtained by dividing the interval into 3 subintervals of equal length and left end points of subintervals for height of the rectangles. That's the complete question.
Okay. So, okay, this is an quadratic, right? This function.
Yes.
Is a quadratic. So what we are asking you is, it's just a Riemann sum application. So in the interval 0 to 6, okay, this is the interval.
Yes, sir.
And when x is equals to 0, it will be somewhere 19 by 6 and it will go like this. Okay, this is how a quadratic equation looks like. Now what we wanted you is, we wanted to find the area under the curve f of x, estimated area under the curve, by dividing the interval into 3 subintervals of equal length. So you tell me, when my interval is 0 to 6, if I divide this particular interval into 3 subintervals, so what are the 3 subintervals will be?
As they
0
are
to 2, 2 to
yes,
4, 4 to 6.
0 to 2, 2 to 4, and 4 to 6.
Yes, sir, even number.
Right. So this is the only possible partition, right? When I say equal interval, 3 equal intervals, this is how I can partition. If I partition in another way, then that will not be equal partition.
Yes, sir.
Right? So
Sir, sir, instead of 6, if it would like 7, sir, then in that case,
7
how
also. See, if we give 7, then we are being more sadistic. Right? We wanted you to compute 7 by 3 values. So we won't see, even if it is 7, you divide the whole interval by 3. So 0 comma 7. So the length of total interval will be 7. You divide the interval length by 3. So each of the interval length should be 7 by 3. So that means first interval will be 0 comma 7 by 3. And the second interval will be from 7 by 3 comma add 7 by 3, 14 by 3. And the third interval will be 14 by 3 comma 7. So this is how the interval breaks. If we have, so whatever the interval we have given you, just find the length of that interval and divide it by number of intervals we want, subintervals we want. So here we wanted 3 subintervals. So the length of this 0 to 6 is 6. So if I divide it 6 by 3, we want 3 subintervals. So each of the subinterval length should be 2. So therefore my first subinterval will be 0 to 2, and from 2 to 4 and 4 to 6. And now after this, if I wanted to compute, or if I wanted to estimate the area under the given curve, I am actually interested to use Riemann sums. When I wanted to use Riemann sums, I actually predict the area by using areas of the rectangles, right? This is how Riemann sum works, no? Correct?
Yes, sir.
So if I wanted to estimate area under any curve, what Riemann does is he will break that area into some smaller rectangles, and he will compute that rectangles area and add all the areas of the rectangle. So now what we said you is consider the left hand point of the subinterval for the height of the rectangle. So if I wanted to draw the rectangle in this interval, consider the height of the rectangle as the left hand point's value. So what is the value of the left hand point?
19
What is the left hand point of this 0, 0, 2? 0. Left hand point.
Yeah.
In this interval, 0 is the left hand point. And at 0, consider the function value, right? Function value is f of 0, and this is this. So consider this as the height of the rectangle. Now this is the height of the rectangle. Okay, this is f of 0. And this is the length of the rectangle, which is 2. So this is how the rectangle will be. So this is the first rectangle corresponding to the first subinterval. And in the next subinterval, what is the left hand point?
2.
This particular interval, yeah, 2. So consider f of 2 as the height of your rectangle. So f of 2 will be this point. Okay, this is f of 2, and the length of this subinterval is also 2. And similarly for the final interval. So when you compute the final one,
F4.
f4 will be the height of the rectangle, and 2 will be the length of the rectangle. Okay. Now we have got, as we have divided it into 3 subintervals, so we will get 3 rectangles. So we have to find the area of each of the rectangle and add all those. So if you add all the areas, so f of 0 into 2 is the area of this rectangle, and f of 2 into 2 is this rectangle area, and f of 4 into 2 is this rectangle area. So this will be approximated to area under the curve, right? This is what Riemann sum is, and Riemann sum is the approximation of the area. So this is 2 times of f of 0 plus f of 2 plus f of 4. So we require f of 0, f of 2, f of 4. We have given f of x to you. From here you substitute x is equals to 2, x is equals to 0, x is equals to 4, and get the values of f of 0, f of 2 and f of 4, and add those and multiply it by 2. So that should be your answer.
Okay, sir. Thank you so much.
सर
Excuse me.
जो एरिया बाकी रह गया उसका क्या था होगा?
This one.
हाँ जो एरिया कवर नहीं हुआ, मतलब ये
yes. इसीलिए this is just the approximation, not the exact. Okay, इसको हम यहाँ 3 इंटरवल्स लिया है, that is why इतना एरिया गायब हो
छोटा इंटरवल लेकर फिर तो सब कवर हो जाएगा.
छोटा see, that is what approximation of Riemann. So when n tends to infinite, we actually compute the exact area. Yes. So if I decrease the interval length to this
rectangle chota like a
chota le lo, like this, and this green part, some part of this green shaded region will also cover in this rectangle. Even if you take much more chota rectangles, then slowly you will end up covering all the area under this curve. Okay?
Yes, sir.
Okay.
So
Okay.
when we find the area under through the integration, then the values of approximate or is a full?
Exact. Those are exact.
Those are exact. No?
See, this is, see, I have given one tutorial also. So when you want to approximate
0 to 6,
there is a given function like this, a difficult, complicated function to integrate sin x by some x square plus 1 minus 2 cos x dx, like this. Okay. This is very difficult to integrate. I don't say it is not possible to integrate, but it is very difficult to integrate, right? If I wanted to find this value, it is better to approximate using Riemann sums by considering f of x as sin x by x square plus 1 minus 2 cos x, like this, consider like this, and you divide this 0 1 interval into some 10 intervals or any number of intervals, or some 5 intervals is also fine. So you will actually go nearer to the exact value. This is an exact value. Using Riemann, you can actually approximate this.
When we function fx is not integrated, then we use the Riemann sum.
It is better to use Riemann sums. Riemann sums are very much more useful when you wanted approximate answer, not the accurate answer. You don't worry about what exact value of exact area under the curve, but you want an approximate value, approximate integer value, let's say. So whether it is nearer to 20 or whether it is nearer to 40 or whether it is nearer to 60. So in those cases, you can actually use Riemann sums directly.
Okay.
Sir?
Yeah.
Sir, I know that the differential calculus, the global minima here, is in data science because using the gradient boost and descent type of things. But sir, this remains on the integral and the computing area, I think. Sir, this will also in data science, related to data science or not that much?
See, everywhere you use this differential calculus and integral calculus. First and foremost thing is when you have graph with you, see, in mathematics that is a curve, but in real scenarios it might be trend of some stock price of some market, some company, or it is referred to some data. That particular graph refers to some data, and area under that graph actually gives you many properties of that particular data. Okay, in order to find this area under the graph, you definitely require integral thing. So this is actually related to data only.
Excuse me, sir. Sir, in the graded assignment 9, there was a question number 4. I saw its solution, but I wasn't able to understand it thoroughly.
Question number 4, is it?
Yes, sir. In graded assignment 9, which says, suppose fx1 is x cube and fx2 is x, denotes the profits of a company A and B throughout 1 year.
And the thing is, we have given this 4 and 5 as an, we are ignoring these questions. Okay, are you aware of that?
Oh no, so I wasn't aware of that, but
okay, the graph is missing in that actually. But anyway, without that graph also can be done.
Yes, sir. Means we will ever be having a question. We can have this kind of questions in quiz 2 and
if you are aware of that, then I will be. For me, it will be easier to discuss.
Yes, sir.
Solve with structure संसन में हुआ था इस type of question.
This question.
Yes, sir.
This
The
type
same question is discuss and solve with this instructor.
Okay, then why not go back to solve with the session and just look at
which session?
Solve with us.
Last
Solve
solve with us session.
with us.
Okay, okay, thank you.
And where we all discuss about when the graph is not given, so how to make a graph and plot the graph and how to conclude the answer.
So this was a small error from our side in this 4 and 5. See, the thing is, it's very easy. X cube, x, root x, and e power x, these are all very easy to draw. That is what we did in that graph also. We just given the graphs to you.
So we can draw the graph, but how to arrange these graphs so we can actually have a meaningful.
See, arrange these graphs means you find the intersection points of these graphs. So that is what it will. When we give the graph to you, then it will be, from looking at the graph, it will be easier for you to find the intersection
There
point.
is given the interval 0 to 1, so it is easy to plot the graph in the interval 0 to 1.
We can evaluate it without graph.
Yeah.
Desmos or Geo graph.
Excuse me, sir. Sir, week 7 graded assignment 1. Can you please explain?
Week 7. Okay, then in that case, let's do one thing. As of now, week 10 we will discuss after quiz 2, from where I stopped. So from reachability, adjacency matrix, reachability, vertex coloring, we will discuss in the next coming session. And this DAGs also we will discuss on that coming session. Okay, then we will discuss some things in week 7 for some 15
So this week 7, question number 1 and 8. Guys, please wait for your turn, and please one by one you ask.
Okay.
Please do not disturb because it is wasting time everyone's.
Okay. Week 7.
So question number 1 and 8. And week 8, question number 2.
Okay. So before this, let me ask you one thing. Have you gone through this solution?
So yes, I mean, actually I went through the solution, but there was some convention error, convention understanding.
Okay, just a second. My internet is slow. Week 7, question number, please.
1.
Okay, 1.
So I have also doubt in same question.
Okay, question number 7. Question 1 is, let A and be two sequences of real numbers.
Sir, could you please share your screen and read the question so that we will also understand?
Okay, just a second. This is the question, right?
Yes, sir.
Okay. Which option is the doubt, or all options?
सर जो एक्सप्लेनेशन दिया हुआ है ना ग्रेडेड सॉल्यूशन, उसमें समझ में नहीं आ रहा कि एक्चुअली एग्जैक्टली व्हाट ही इज ट्राइंग टू से। आई गॉट फुल्ली कंफ्यूज्ड।
अच्छा, इन द एक्सप्लेनेशन सॉल्यूशन
हाँ, जो सॉल्यूशन उन्होंने दिया है तो उसमें क्लैरिटी नहीं मिली कि व्हाट एग्जैक्टली क्वेश्चन इज आस्किंग एंड व्हाट इज ट्राइंग टू से।
Okay. So I guess let me open the solutions thing. Okay. Graded assignment solutions. No? Okay, week 7. Okay. So A and B two sequence of real numbers. Let an is equals to 1. So he is taking an example he is taking a counter example to prove that particular statement is wrong.
सर इसको थोड़ा सिंपलीफाई करके समझा दीजिए, नहीं तो फिर इसमें गो थ्रू करेंगे।
Okay. So see, option 1. Sorry. See, कभी भी when you wanted to prove something is true, हम actually prove करना है उसको. But लेकिन when you actually wanted to reject, or when you actually wanted to say it is an incorrect option, it is enough to bring a counter example to this. Okay.
Okay, sir.
First option देखो, a and bn both converges to some non-zero real number. Okay, so what we take is sequence an as a constant sequence which takes 1 1 1 1 1 like that. Okay, an is equals to 1 for all n. So the sequence goes like this: 1 comma 1 comma 1 comma 1 comma, and so on till infinite. So is my sequence an convergent? बोल सकता हूँ क्या?
नहीं, with that alone I cannot say no, sir.
No, see, I define an as 1 for all n. So that means my sequence is 1 1 1 1. My nth term is also 1. My 1000 term is also 1. Like this, it goes
So
like
it's
this.
not converse.
So limit n tends to infinite. What will be an?
1.
1.
1, right? So for any term in this sequence is 1. Even it is 10,000 or even it is 1 lakh or even it is 20 lakh, even it is 1 crore term. So even there also it is 1. So even n tends to infinite also. That means even my last term will also be 1. So when limit n tends to infinite, this particular sequence actually takes value 1. It is not going to take any other value. Correct?
Okay.
So limit when this particular limit is going to take only single unique value, then what we will say, this particular sequence an is convergent, right? Look at the definition of convergent and divergent, which we discussed. So this particular limit should actually tend to one particular value, unique value, not even to two different values, unique value. Then we say sequence an is convergent. But if this particular limit goes to plus infinite or minus infinite, or it is going to two different values, then we say that is a divergent sequence. Okay. So in
Okay,
this
sir.
case, we are getting only single unique value, right? Our limit an is tending to 1 only. Therefore, my an is a convergent sequence, and also it is converging to a non-zero. This 1 is a non-zero number, right?
Yes, sir.
Excuse me, sir.
I am taking it as -1 for all n. For all n is equals to 1, 2, 3, and so on. So how this sequence will look? This will be -1, -1, -1, and so on, -1, and so on. Even as n tends to infinite, also it will be -1 only. It won't change. For every n, my term will take the value -1. So when I see the limit n tends to infinite, bn, what this value be?
Again, -1.
-1. Right?
And this is
Even
also
-1
convergent.
is also a non-zero number.
Yes. And so this is also will be convergent.
Yeah, this is also convergent, right? This is also going to -1. One particular
Yes, unique value.
Unique value. So bn is a sequence that converges to non-zero real number. An is also a sequence that converges to a non-zero real number. But now see, now let me consider an plus bn. What will be an plus bn?
0.
0. Correct? For all n, right?
Yes.
For all n, 1, 2, 3, and so on. So how will my sequence an plus bn look like? 0, 0,
0, 0.
0.
So till infinity 0.
All zeros.
Yes.
All zeros. So where will my limit n tends to infinite? This particular an plus bn tends to
Also 0. It's also 0.
0.
0. So now you can see what is our statement here. First statement. It says if an and bn both converge to some non-zero real number, then an plus bn also converges to some non-zero real number.
No, sir.
So they say this happens, but we found a contradiction that even though an bn converges to some non-zero real number, there is a chance that an plus bn converges to 0. Right? Just now we have seen with a counter example. So once you have an example with you, then I can say this is an incorrect statement. This is not true for every an and bn. Okay. I can actually find two sequences an and bn such that this statement is false. So those two sequences are an is equals to 1 and bn is equals to -1. So we are actually proving this statement wrong by taking the counter example.
Okay, sir. That's it clear.
Yeah. Next is if an is a increasing sequence, that is ai is less than or equals to ai plus 1. So increasing sequence, decreasing sequence, we know, right? So what is there in the solution? Okay, directly given, is it? Yeah, even here also he took a counter example. What he took is he has taken the natural number set excluding 0. So when a first term is 1, second term is 2, third term is 3, like this 1, 2, 3, 4, 5, 6. So this is an increasing sequence, right? Each of the term value increases. First term is lesser than the second term, is lesser than the third term. Correct?
Yes.
So consider it as 1, 2, 3, 4, 5, 6, 7, and so on till infinite. So each of the previous term is smaller than the next term.
Yes.
Now, if that is your sequence an, now how will be this -1 to the power n times an looks like? So just multiply. Okay, let me show you that thing also. So what I consider this sequence as 1, 2, 3, 4, and so on. So this is my sequence an, where an is n, right? Nth term is n in this sequence. So there is a new sequence which is -1 to the power n times an, which is -1 to the power n. An is n here. Just substitute that n. So how will my -1 to the power n times n look? So when n is equals to 1,
-1
-1.
so this is how sequence looks. So if I simplify this, I will get -1. This is -1 to the square. This will be +1 and it is 2.
-3
This is -3 minus, see, this is
+4
4, and next you will get
-5
-7, like this. So if you see here, so firstly this -1 is less than 2, correct?
Yes. Yes.
But this 2 is greater than -3 here. And this -3 is less than 4.
So it would be
So you see,
divergent.
this is not even not decreasing as well as it's not increasing function.
Okay.
Sorry, sequence. Correct?
Yes, sir.
So this sequence is neither increasing nor decreasing. But your sequence an is an increasing sequence. You can see 1 is less than 2, 2 is less than 3, 3 is less than 4.
Okay.
So this is an increasing sequence, but this is not an increasing sequence. You are getting less than, greater than, less than, greater than, right? So that is what statement 2 also tells us. Okay, like this he has explained. And next thing is, see, third, what is the third statement? This is just the property of so this is just the property of limits. So you have two sequences with you, a and bn, both converges to some non-zero real number. Then a and bn also converges to some non-zero real number. So converging to some non-zero real number means limit an.
So we're not able to hear you.
Hello? Am I audible?
Yes, sir.
So
Yes, sir.
Array. Okay. So this is the property of limits. See, if an is converging to some non-zero real number means limit n tends to infinite take some value, right? Hello.
Sir, by the property of the this limits, so like in the first example, na, option A and option C both are similar, only that is addition and this is multiplication of the both the terms.
This is multiplication, right?
Multiplication and that is addition.
That
So
is
is this the property that we can conclude if A and B and both converges to some non-zero real number, then multiplication will also result in some non-zero real number? Or do we need to calculate that, okay, taking that example, or we can say by the property itself, we can say addition is not, but multiplication is.
Okay. See, let me then define it in a general way. If you can understand this or not. Okay. So I have taken examples, right? Now I don't want to take examples. So I say sequence an is a converging to a non-zero real number. Okay. When I say this statement, am I still in the call?
Yes, sir, I am there.
Yes, sir.
This statement is equivalent to saying that when n tends to infinite, this particular sequence will go to some value a. So where a not equal to 0. Is this true?
Yes, sir.
Yes, sir.
And similarly, limit n tends to infinite, there is another sequence bn. It is also converging to a non-zero real number, where I say this is b, converging to b. Okay, where b not equal to 0.
Yes, sir.
Now see, now observe. What will be limit n tends to infinite, an plus bn? I can write this as limit n tends to infinite, an plus limit n tends to infinite, bn. Can I? This is one property of limits, right?
Yes,
I can
sir.
actually split that. So what is limit n tends to infinite an? This will be a. Before. Just now we have
Yes,
defined
yes, sir, yes, right away. A and then that will be B.
A plus b. So now see, this limit goes to a plus b. So what is the statement given is, this a plus b, given statement is if a not equals to 0, b not equals to 0, then a plus b not equals to 0. Is this statement true?
Yes, sir.
Yes, sir.
Is this true?
Yes, sir.
Yes.
Okay. So tell me, what if a is minus 2, b is plus 2?
Not addition, no.
This is addition.
Yeah, you will get 0.
Yes. Okay, so that will not be equal to 0 and a plus b.
Is it mandatory that a plus b not equal to 0?
A plus b not.
Not mandatory, right, sir?
It's not
Yes.
mandatory, right?
Yes, yes.
We can find examples of, we can find values of a and b such that a plus b becomes 0. You take k and you take b as minus k. So if you
Yes,
add these two, you will get 0.
Get 0, 0. And so not necessarily the addition of A plus B will get to 0. So that
A
is
plus B get to 0. That means this limit value or this sequence an plus bn, you cannot say that this will actually converge to a non-zero real number. It can be A plus B can be 0 or A plus B cannot be 0 also. Both cases can happen.
But sir, can we say it will also be convergent? Okay, a non-zero real number will not get a 0, but can we say it is converging or no? By just let us say it as
Convergent.
Converging, constant value. Yes, because A plus B, because whatever from A I will get and B and I will get, so that way itself will give a converging value because that is constant value I will get, so that will be convergent, right?
Yeah, that will be convergent. Now see, option C tells us limit n tends to infinite an times bn. Okay, this can I write it like this? Limit n tends to infinite an times limit n tends to infinite bn.
Yes, sir.
Yes, sir.
Hello.
Yes, sir.
Yes.
Yes,
Okay,
sir.
I can write it like this, right? See, my internet connection is.
Yes, sir. Some in between. Actually, we are not able to hear.
Yeah,
I
it is
think-
breaking, connecting, disconnecting, connecting. I don't know. She's playing with me. Okay, this thing will become A times B. Okay. Now see, this is some properties of real numbers. Just convert this as property. If A not equals to 0, B not equals to 0, then will it imply that A times B not equals to 0?
Yes, sir. Yes, sir. Always.
This is true, right? This is always true. If your A is not 0 and B is non-zero, then product will obviously be non-zero.
Yes,
correct? So therefore, from there this will come. So if your sequence an and if your sequence bn converges to non-zero, then an bn also converges to non-zero. Okay, so even here I can conclude that this product AB will not be 0. So this product is something non-zero. Always it converges to a non-zero value. Okay, but addition is not true. Addition we have counterexamples.
Yes.
So look it like this. Okay.
Thank you, sir. This is very clear now. Sir, could you please go to the next option? Is it there, or else we'll go to question number 8?
Next option is just the subtraction.
Okay.
A and B n goes to the same real value. Now A equals to B. Okay.
Subtraction also going to be a true, right, sir?
Next option is also going to. See, now we say.
So that will not be non-zero, sir, because
A n and B n converges to the same value. So now A will be equal to B. Okay.
Okay, so plus 8 minus 8 will become 0, na? So that will not be true. Like addition, na? Subtraction also will not hold true.
Now it is subtraction. It is given. Now option C given that limit n tends to infinite an is equals to limit n tends to infinite bn is equals to some a. Now they ask you that will this sequence an minus bn always converges to 0 or not?
Always converges to 0.
Always converges to 0 or not? Just find limit n tends to infinite an minus bn. This will be limit n tends to infinite an minus limit n tends to infinite bn. So this is a and this is also a. This will be 0.
Yes.
So therefore, it will always converge to 0. Okay.
Just a small query. Sir, when do we, how do we know whether to use integration or Riemann sum in the exam? Will it be mentioned?
In quiz 2, there is no Riemann sum at all.
Oh, okay.
Till week 8 only. There is
Oh,
week
yeah.
9
Okay.
Sir, question number 8, please.
Question number
8. This one, greater 7. Question number 8. सर उसमें अच्छा जो सोल्यूशन है ना उसको समझ में तो आता है बट बीच में उन्होंने जो टर्म लिया है जस्ट ओनली दैट पर्टिकुलर थिंग आप एक्सप्लेन कर दीजिएगा जो explanation sheet है ना,
Okay,
उसमें
okay. I will just open the explanation.
only one line that I'm getting confused.
Question number 8, is it?
Yes, sir.
That limit of.
That is clear, but वो बीच में कुछ टर्म उन्होंने ऐड किया है तो वो थोड़ा सा क्लैरिटी है। हाँ, यहाँ पे जो n factorial to the power 1 by n उन्होंने ऐड किया है। So how did he come to know like that complete denominator जो factor ना complete थोड़ा सा उसको बता दीजिएगा कि how it is helping him to get that idea of how did he get that term itself to multiply and divide?
See, how did he get that idea? Because we have given you above पे देखा तो we have given you some standard limits values.
अच्छा, उसी के लिए to bring into that form he has multiplied into this.
Yeah. So to bring it to that form, we actually multiply, divide and multiply, subtract and add. These are all things. Why we do these things is because to bring it into some standard well-known form.
Okay, sir. सर और एक जो लिमिट का जो फ्लोर फंक्शन होता है ना, जैसे 3 प्लस है या 3 माइनस है, तो जब हम लिमिट का वैल्यू उसमें डालते हैं तो whether we need to take that 3 plus that 3 value or we should take something 3 plus means we should take the value 4 or minus 1 means like we should take less than the value. So that floor वाला एक example के मैं बता सकते हैं।
Floor example, where is that floor example?
सर क्वेश्चन अब अगर आप जाएंगे ना ग्रेडेड असाइनमेंट 8 क्वेश्चन नंबर 2 उसमें एक एग्जांपल है दैट डिपेंड्स।
ग्रेडेड असाइनमेंट 8 क्वेश्चन नंबर 2।
यस।
Okay.
Floor function.
Okay, floor function.
Yeah. So when that 3 plus or 3 minus we are giving, so how what exactly value we are putting there? Like is it the So maybe
3
then
plus. Okay, let me conclude. 3 plus मतलब 3 से थोड़ा ज्यादा. So that means 3.01 or 3.001. 3 से थोड़ा ज्यादा से. Okay. What is step 3.001?
3.001. That is 3 plus, no?
Yeah, that is 3 plus. What will be the value exactly?
Value means like I will put 3 only there, no? Or should I put more?
See. Okay. When you know floor function, right?
Yes sir. Actually वो जो वैल्यू डालते हैं ना वो थोड़ा सा क्लैरिटी नहीं मिल रही एग्जैक्टली हमें 3 डालना है या उसे 3 से ज्यादा डाल के उसका वैल्यू जब हम पुट करते हैं ना when we are putting that value.
Okay. What exactly floor function means is you write that is a function basically. What will be the output of that function means whatever the input you give, the output will be greatest integer that is less than or equal to the input value. So if my function input is 2.5, so floor 2.5 will be the greatest integer that is less than 2.5. What is the greatest integer that is less than 2.5?
3.
Greatest integer that is less than 2.5.
Less than 2.
2.
Yes.
So 2 is the greatest integer, right? So less than 2.5 there are infinitely many integers. So 2 hai, 1 hai, 0, -1, -2.
Yes.
These are all integers which are less than 2.5. Among these integers, which is the greatest one or the largest one?
2.
2.
Yes.
So that is how this floor function is defined. जो भी real input you give.
Yes. Sir, वो तो वो मैं समझ गया but वहाँ पे जो 2 plus लिखा है ना तो what I need to अच्छा you need to say if it is limit extends to 2 plus in the floor function itself I will put 2.5 and when I'm getting the value of the 2.5 I will get the highest integer lesser than 2.5 so that will be 2. Is it the meaning? Sir, am I audible?
Hello.
Sir, am I audible?
Yeah, I'm losing connection continuously.
Okay. So sir, यहाँ पे जैसे लिमिट एक्सटेंस टू 2 प्लस है ना तो जो लोअर फंक्शन में मैं 2 प्लस यानी कि 2 से ज्यादा 2.5 डालूंगा और जैसे 2.5 लोअर फंक्शन में डालता हूँ तो लोअर फंक्शन ऑफ 2.5 इज 2. So that is the meaning.
हाँ 2.5 तक नहीं चाहिए, यू जस्ट पुट 2 प्लस, मतलब थोड़ा सा ज्यादा है 2 से,
अच्छा, okay,
so that is 2.1. even 2.001, see this is a real number, 2.0001 is a real number. उससे नीचे the greatest integer, what is the greatest integer that is less than or equal to 2.0001?
2
only. तो
Two,
सर
right?
अगर
Like that.
ओके, तो सर अगर 2 माइनस होता देन
2
व्हाट
माइनस होता तो 2 से कम है,
यानी कि 1.99
98 और 99 ऐसा.
उसमें डालना है और उसके बाद लोअर फंक्शन उसका लेंगे तो फिर अगेन इट विल बिकम द 1, राइट?
It will 1, it will become 1.
एक एग्जांपल डालेंगे सर यहाँ पे थोड़ा सा नोट कर लीजिए.
Example on floor.
हाँ हाँ यस, जैसे लिमिट एक्सटेंड्स टू 3 प्लस और 3 माइनस करके एक एग्जांपल दिखा दो.
Okay, so see, let's consider this thing. Okay, so now limit extends to some 4 plus, I say.
Okay.
4 plus f of x. So this is basically limit x tends to 4 plus step x, sorry, floor x.
Yes.
Both are. So now see, when x is coming from right side of 4, so this is 4, my x values are right side of 4, यहाँ से आ रहा है, limit slowly tending to 4. Okay, my values are right side of 4, so whatever the value I choose that is greater than 4.
Yes.
Right. Now slowly this will be limit x tends to 4 plus this particular thing will become 4. So whatever the value I take greater than 4, my step of my floor of 4 point something. So this is nothing but I can write it like this. This is limit x tends to 4 plus, I can write it as h tends to 0, step 4 plus h, some smaller h which is greater than 4. So this particular floor will be 4 itself.
Okay. Okay, sir. Then अगर ये minus होता, then it will be 3.9 and again it will be 3 value.
Yeah, this is when x is coming from left side of 4, f of x,
then it
this will be equal to 3.
Yes, yes, okay.
I
And
have
if
two
it is,
queries, sir.
sir, अगर वो थोड़ा ऊपर ceiling function होता, then it will be
opposite.
Opposite in
That
the
will be
will be 4. नीचे वाला 4 होता और ऊपर वाला 5 होता.
5 होता.
Okay.
Simply remember this. Floor is nothing but greatest integer value. Okay. And this is floor. Ceiling मतलब ऊपर. Floor is नीचे, ceiling is ऊपर. That is least integer. Greatest integer less than x, least integer greater than x. Okay, so 4.1 से ऊपर infinitely number of integers होता है, 5 होता है, 6 होता है, 7, 8, 9, 10, many. Among those you find the least. So 5, 6, 7, 8, 9, 10 में least क्या है? 5. So that will be the floor. Sorry, ceiling. This is floor.
Okay, sir.
Sir, graded assignment 3.
Sir, in this,
Wait, Rohit, you ask.
Sir, I have question related to
Divya,
this
just
only.
wait. Divya, can you wait for a moment?
Yes, sir.
Sir, in question number 4, sir, last Friday I also said that it is counted in week 3 graded assignment.
Week?
And sir, 3 graded assignment, the question number 4. So minus 50 and plus 50 the answer question. So in the announcement,
I'm not able to recollect. Question number 4, is it?
Yes, sir. Graded assignment, question number 4, week 3.
Week 3?
Yes, sir. Sir, I have problem related to marking, sir.
Marking
Sir,
add हो जाएगा. Add या
no, sir.
subtraction.
Sir, I think in in the announcement, there is an announcement that we not need to supposed to add that question in the model. But sir, still it is evaluated. So, last Friday you said that you will rectify it.
This question is it?
So it's really not
See, okay, am I not sharing the screen?
you are sharing a particular thing.
Week 3 graded, this is the week 3 graded question number 4.
Yes, sir.
Okay, you haven't got your marks set. Is that what you?
Sir, I have the marks, sir, but it's 0, sir, and there are 2 answers for that question. That is plus 50 and minus 50. So sir, I typed minus 50. There's an announcement. So there's an announcement that we will not evaluate this question number 4 in the final marking. But sir, still it is today is week 9 or week 10. We are in week 10. So it is not rectified for marking.
Okay, see, we
so
are
basically maximum
that
mark is for
question.
90.
See, we just removed that question.
But sir, in my case, it is my marks is maximum marks is 20. I get from 20, but I supposed to get from 90.
Now it is showing 19, is it?
No, sir. It is showing out of 20. I evaluated. I summed it. I get 16 marks. Okay.
Okay.
In that week 3, and out of 16, yes, sir, 16. So my percentage is showing it 80.
Okay.
Okay, sir. So 80 is only possible when we divide it by 20. 16 divided by 20, you can get 80%.
Okay, okay.
And sir, it is supposed to 16 divided by 90. That will I get 84%.
It is showing how much? Is it lesser or greater? What is your percentage now?
Say my percentage is right now 80, sir. 80.
Acha, 80. So it should increase. If you are claiming that if you remove this question, my percentage should increase.
Yes, sir, 84. It will become 80.
अभी तक increase नहीं हुआ है.
नहीं, yes.
Okay.
Sir, same with me. Exactly same problem. I've written number of times. It hasn't changed.
I also moved that. Yes, sir,
let me ask the support team what they did.
Yes, sir, one more.
Actually,
sir,
we have said it is being removed and it will be evaluated.
Yes, sir. Yes, sir. Yes, I know, sir. You said that. But still, I think from the technical also, I mailed also. I mailed them this.
Okay. Let me ask from my side then.
Okay. Yes, sir. One more issue. Sir, in the My Dashboard, sir, document for download. Okay. Document for download. In sir, answer transcript for the quiz 1. So in my case, it is showing 404 error, page not found. When I want to click on the download, the answer script for quiz 1.
Okay.
That is showing page not found.
Page not found. Okay. So quiz solution and that graded assignment 3 mark. Okay, I will get back to you on this after reaching out to support technical team.
So can I give you a revise on my rule number or something?
No. See, if you didn't get that, then definitely every student might not have got that. So they might not have updated it. Okay. When scoring comes into the play, then they will be counting all this, I guess. I hope so. But let me ask from my side, and in the next session, maybe I will respond to this.
Because answer one more thing, please, sir. So you also said you asked this quiz 1 answer script, but I am not able to.
Yeah, quiz 1 solution also I will.
Answer script. Or in my case.
Yeah, answer script.
सर वीक 5, 6, 7, 8 का जो लेक्चर स्लाइड्स हैं तो इज दैट नॉट शेयर्ड विद अस?
इट इज शेयर्ड विद यू. रिसोर्स फ्रॉम इंस्ट्रक्टर टैब्स में खोलो.
सर इसमें मैंने देखा था एक्चुअली 1 to 4 तो शेयर्ड है बट 5 to 8 शेयर नहीं है. कुड यू प्लीज सी दैट? If you want, shall I share my screen and show it to you?
No. I will show you where to find it. तो यहाँ है वीक 5 पे क्लिक करो.
नहीं सर इस पे नहीं. प्लीज कम डाउन.
Go down.
Please come down. जो लास्ट में
no, वहाँ नहीं है, वहाँ नहीं है, यहाँ है.
अच्छा 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 मींस
So
रिसोर्स
each of
में
the
सर
week resource from instructor tab खोलो. So click to view all the supplementary content खोलो. And here you can find slides, lecture transcripts, tutorial transcripts. Okay.
okay sir. Actually, I was searching at the bottom of that.
Yeah. Even in week 6 also go to resource from instructor 6. You will get slides of week 6.
Okay.
Okay. Yeah. Okay. Okay then.
Sir, may I ask? May I
Yeah.
ask?
Sorry. Yeah, you can.
Sir, can I ask?
Divya.
Sir, I have, yes, Divya. I have two questions. One is from graded assignment 8, but one is related to what you've just done. Supposing if I'm finding the floor as well as ceiling of the integer 4, will they be both the same?
Integer 4.
Yes.
Integer 4 is same.
So the floor will be also 4 and then the ceiling will also be 4.
Yeah, for all integers.
Okay. The other question is in graded assignment 8, could you please help me understand the solution to question number 8?
Question number 8. Okay. My screen
Yes,
is
sir.
visible, right? Okay. So there is a function given to us, right?
Yes.
This is the question, right? It may not be the same. It might be parameterized. Value might be changed,
Yes.
but the question,
Yes.
ultimate
Yes.
question is this: f of x is continuous at x is equals to 0. Then find the value of. So when I say continuous, your left hand limit and the right hand limit, and the function at that point, value of the function at that point should be same.
Yes, sir.
Right? Should be equal. So that is the condition you should attempt here. So do I have to show the solution or do I have to perform the solution? So let me see what they did. If I can communicate there, I will show it there, or else I will take the link. So what is this? Week 8, right?
Yes, sir.
Week 8 question number
8.
this thing, right? This is the question, right?
Yes, sir.
Let me zoom this. Okay. So see, they have performed. See, our condition is the function is continuous at x is equals to 0 means that means the limit at x is equals to 0 f of x should be equal to the value of that
Yes.
function. So they have used that limit x tends to 0 f of x is equals to limit x tends to 0. They just substituted f of x sine 14x plus a sine x by 19x cube.
Yes.
So when I substitute x is equals to 0, I'm going to get 0 by 0 form, which is an indeterminate form.
Yes.
Use L'Hopital rule.
Yes.
Right. So after using L'Hopital rule, we get 14 cos x. So for sine 14x, when you derive it, we will get 14 cos 14x.
Yes.
Similarly, a sin x, when I derive it, it will become a cos
A
x.
cos x.
And in the denominator, it will be 57x squared.
Yes, sir.
Right. Now, if you see, if I substitute 0 here, I'm going to get
0.
The numerator is 1,
Yes.
right? Not 1. The numerator is something like 14 plus a. 14 plus a. But
Yes.
denominator is 0.
Yes.
So 14 plus a divided by 0 is something like you see it will not be an indeterminate form unless numerator becomes 0. Right?
So this is not indeterminate?
See 14 plus a, if a is something other than minus 14, if it is something you say 2 or 3 or 4, then that is numerator is an real number divided by 0. this will go to infinite, right? This one, any real
Yes.
number divided by 0
Yes.
is infinite.
Yes.
But we said limit actually exists at that point. We said actually it is continuous. That means limit must exist,
Yes.
right? So that means eventually what we get is the numerator should also be 0 so that it becomes an 0 by 0 form, indeterminate form, and we can actually again use L'Hopital rule.
Yes.
Okay. So in that case, if I wanted to equate numerator to 0, that means 14 plus a, if I equate it to 0, I will get a as minus 14.
Okay,
Right?
that's what I didn't
When my a
understand.
is when my a is minus 14, now you take a as minus 14, then now just compute limit value. Try to compute the limit value. Then you will get in the second step, you will get numerator is also 0 and denominator is also 0, and again you will end up getting indeterminate form. Again
So
we
that
will
means we can't use L'Hopital's rule if both are not 0, numerator and
both are
denominator.
not 0. See, L'Hopital rule we can only use if it is in the form of 0 by 0 or infinity by infinite or
Infinity
minus
or
infinity.
minus infinity. Okay. Okay, but
That's
one
it.
is actually tending to some particular value while the other is 0. Okay.
Not that is not an indeterminate form.
Okay. And this is what I didn't understand, how we got the a is equal to minus 14. Why are we assuming it will tend to 0?
To make that as 0 by 0 form. So to perform L'Hopital rule and all this, we actually took a is equals to minus 14. If I didn't take 14, then the limit will go to infinite, and we will say limit does not exist.
All right. But we know that the limit
will
is
not exist.
existing. Yeah.
Here limit exists. If a is minus 14 only, limit exists. If a is other than minus 14, limit will not exist at all. Okay.
So, sir, L'Hopital's rule we use only when we find the value of some a and b, or we know that there is a function is also has a limit and have a continuous function.
Yeah. So here we have two conditions, two variables can be formed. So limit should exist and the function should be continuous.
Then we use the
So
L'Hopital's.
yeah. So limit existing gives you the value of a, and continuity gives you the value of b.
Okay, sir. Thank you.
So,
Yeah.
excuse me, sir.
Hmm.
Actually,
Emma, I have Emma.
yes, that's me only. Yeah, that's me. Sir, can you put an on-demand session, because I have a lot of doubts in many of the activities from 5 to 8 for the quiz.
5 to 8.
Yes, many of
Okay, let me explain you our schedule. Okay, so you are qualifier batch students, right?
No, I am term 1.
Okay, whatever. You are taking max 1. For you, there is a quiz 2, right?
Yes.
For few people, there is a qualifier 2. Okay.
Okay, yeah. Hello.
And even they are going to give the entrance exam.
Hello.
Hello.
Yeah, am I audible, sir?
Yeah, you are audible. I lost connection in between.
Yeah, okay.
Okay, so you are giving quiz 1.
Yes.
There are students who are going to give qualifier 2 and the same time, March 13 itself.
Yeah.
Okay. And there are students who are coming directly to diploma. So they are going to do the max 1. Okay. So we are going to conduct sessions for all these people. So I'm explaining my situation. Okay. Why we are not taking on-demand sessions regularly is of this reason. So here we have to take sessions for all these students, right? Even how you are a student to us, even they are also student to us.
Yeah.
We have to take care of them.
So how do we have to then?
See, the thing is, one thing we can do whenever we take a session, it is for only 2 hours, but what we can do is we can increase 1 hour extra and we can take it for 3 hours, and we will try to complete it as quick as possible. So there is a revision session which will be happening on Tuesday after mock. There will be a revision session. In that revision
No,
session,
actually, what I thought is there if if there is a revision session, one before a mock, like other subjects, they are all taking enough revision sessions, to at least minimum 2.
Say, that is why I explained you situation. Don't compare mathematics with other subjects, okay? They have enough instructors.
Sir.
एक्चुअली आपका पढ़ाने का तरीका ना, the way you explains no, it's really बहुत ही ज़्यादा अच्छा डाउट क्लियर होता है. So people really like to be part of your explanation team, and that is the request that people are doing.
I think the connection is again lost.
Yeah. Hello, sir.
Sir, are you there?
Hello. Hello.
Sir, are you there?
No.
Hello.
Okay,
Yes, sir,
sir.
now we
Then
can-
next
now we
session will be in the same schedule. So in that session, you will extend. That means to say.
We can extend. So we can
Yeah.
extend that
So
session.
with next
or,
session, I'll ask my doubts, whatever are there.
yeah,
That's
you
it.
can ask your doubts at any time. See, I as far as I am concerned, I will take every doubt. Okay.
Yeah, I know
Until
that, sir.
unless everyone leaves, I will take the
Yeah,
note,
yeah, I know
whether
that.
it
Sir,
goes to 3 hours or 4 hours.
Sir, that means we on Tuesday we're not having solve with us this time.
No. See.
So on Tuesday we are having your class or not?
Sir?
Having
Hello?
revision session or
Sir, I think has lost connection.
No, to Tuesday there is no solve with
Guys,
us.
one general question to you people also. Out of 12 assignment, best 5 best they can take, right?
The question was not audible. Can you please repeat again the question?
I'm asking that out of like 12 assignment,
7.
they consider 7 or 5?
For final assignment is 7.
Best,
7 best.
Best of 7.
I think 7.
Is it not 9?
Yeah, and hey guys, I also want to know any passing marks for going to.
Okay, am I audible?
Yes,
Happen on
Yes, sir.
that 13th of March, right? Hello.
Yes, sir.
Okay, let me complete my statements and you guys can discuss. Okay, just prepare these 2 days thoroughly for Max 1 and give the mock. And this Monday, you try to solve the mock. If you are unable to solve it in the given time, you just sit, you try for it yourself. Just try to get. If you are unable to solve, just go with your friends or just reach out to your friends. Try discussing among yourselves. And on Tuesday, we will meet and we will discuss mock and we will revise and I will discuss doubts, clarities, questions, whatnot, everything on that day. So the session starts at 4 p.m. So as it starts at 4 p.m., we can actually go till 7 or 7:30 or till 8. So I will
Sir,
sit.
there is one more session before that also. There is, before solve with session, there is one more session which is scheduled, which I'm seeing in the Google calendar.
Even that will be postponed. See, the schedule will all change within, I say.
Oh, so that also you are not taking this time. Oh.
That is also
Hello.
postponed.
Oh.
So no solve with us on Tuesday, right, sir?
No. On Tuesday, there is only revision come doubt clearing sessions of week 5 to 8.
Okay, sir. That's nice.
So will it be okay in one day? I don't know. So any
It is on Tuesday,
questions,
right?
whatever we have, if we post it on the forum, will we get reply in just half an hour or 1 hour?
See, within half an hour or within 2 hours, you will get a reply. Okay.
In the forum.
We know that this week is an exam week. We will thoroughly check all the discourse forums and everything.
Please do that, sir. Yeah.
Yeah.
Need your
There's
help.
also a session on Friday,
Sure.
right? On 11th.
Prepare for exam and give mock.
Yes. Okay, sir. Actually, this is my doubt. Just need thorough help because I have a lot of issues with maths right now. So that's why. Thank you, sir. Just immediate. Whenever I have doubt, I want to. I'll post it in the forum.
Yeah. Sure. We will reach out to you within before 2 hours.
Yeah. Thank you, sir. Yeah.
So we can ask on Friday also, right?
Which Friday? This is the Friday, right?
No, sir. As in 11th, the Friday before the exam.
See, that depends on Tuesday session. Okay. So if I can complete everything, if I revise everything,
Excuse me,
and
sir?
if I had cleared all your doubts on Tuesday, there will not be any session on Friday. If
Okay,
not,
sir.
there will be a session on Friday also.
So next session you're going to take on Tuesday, right, sir?
Yeah, Tuesday.
Okay.
Excuse me, sir.
Yeah.
Sir, is there any passing marks on quiz 2? I think there is
Partial
not
marks.
any passing marks, right?
For MSQs, there are partial marks.
No, passing marks for this quiz.
Passing
quiz
marks. Okay. No.
40.
You can actually leave quiz 2 if you don't know.
And for final exam, sir?
Final exam there is. So see what might happen is
hello.
If you are not giving quiz 2, then only quiz 1 marks is being
Yes, sir.
considered of you.
No,
Sir,
suppose sir, I got less than 40 marks in one of the subject in my final exam. Then what would be happen?
Then you will fail
I
in
will
that
get
particular
back
exam.
in one subject, or I will be failed in all the subjects.
No, you will get back in only that particular subject.
Okay. That particular subject, right? That part I will be get back in that particular subject, right?
Yeah, you'll only feel that
Two hours
subject.
today.
You only need to retake that subject.
Yeah.
Yeah, you are allowed. You will only fail in that particular subject.
Thank you.
Okay.
It's
Sir, final exam is MCQ, right? Same like quiz.
Final exam is also MCQ, MSQ, and it is same like this. No descriptive.
So for this question,
and sir, you had told me for a calculus book.
Calculus book.
Yeah.
Acha. Okay.
Yes, sir. And due to some disturbance, I was not able to attend your sessions, 1 or 2 sessions. So I didn't ask for.
Okay. I might have searched that day and I forgot it today. Okay, I will just go back and search for a good book.
So I had
Okay, sir.
On Tuesday, I will definitely give you. Okay.
We will. Okay. Thank you, sir.
Okay, thank you, sir.
Thank you. Thanks.
Thank you, sir.
Thank you very much, sir. It was really insightful session. Thank you very much, sir.
Okay, then all the very best for your quiz too.
Sir, I still have it.
Thank you, sir.
Sorry, mock. All the very best for.
Sir, we have a fear for math.
That happens.
डर लग रहा है मैथ पे सर.
Okay.
Especially sir, this 6, 7, 8 weeks.
Will it be easy, sir?
Grammar will be easy.
This time, like how qualifier is.
This will be. See, the thing is, it depends on. I don't say it is easy, difficult. It depends on way you prepare. It is directly proportional to how much you prepare. Okay. It might look difficult if you didn't prepare at all.
Sir, इस बार डर लग रहा है sir.
No, don't worry. See, the thing is, if you are
feeling anxious, sir.
Feeling?
Sir, actually, what is happening with math, sir? For example, this answer of this question, okay, some steps they have escaped, right? So what happened when we when we later point of time, when we again go back and review this answer. So some if one step is like they skip one step, so we didn't like identify from one step to like third step how they come into like from one step to third step. So that is that is a point, sir. It is like hard to understand sometimes.
See, this is again a debatable thing, I guess. See, we wantedly skip the simpler steps because see, spoon feeding always doesn't work every time. What we expect from you is if we are going to skip from one step to another step, you actually have to fill that bridge between step 1 and step 3. See, initial weeks we have given you a detailed explanation of solutions. When if you have seen week 1, 2, 3, 4, 5, so
Sir,
that is just to give you an idea how a solution look like.
Sir, I'm not like talking about this week 8, sir. If you can go open, sir, week 9 solution, sir. For example, last question, if you see, like it is very hard to understand the last questions, how the conclusion come in.
Okay.
9th question, sir. For example, go to 9th question. Well, it is very hard to understand. 9th one and 8th one, sir.
This one, is it?
Yeah, sir. See some steps if they have skipped out.
Okay, see,
I bet
if you
you
have solved activity questions, by now you should have known how to find the local minimum or local maximum. See, these are the important steps that involve. See, for finding a local minimum, local maxima, you find f of x.
Sir, week 9 is not included in this quiz, right? No?
In this case, there is no weak 9. See, you have to find f dash of x. You have to equate f dash of x to 0. And later you find the critical points by equating f dash of x to 0. And then you will check the sign of f double dash of those critical points.
Yes, sir. Actually, later point of when I like review like twice and thrice, then I understood this steps.
See,
Actually,
these are the important steps. Okay. And we expect in intermediate steps, you should actually be aware of. Like by now, you should be aware of those things. That is what we expect. Okay. Hello.
So could you please go to week 8 solutions? Sir, in that question 11 was open, right? I had a doubt in that.
Question 11.
Yes. Sir, the third line which starts with now, I didn't understand that line.
See, that is what we discussed, right? In order to get 0 by 0 indeterminate form, even the numerator should be 0.
Yes, sir.
Numerator should tend to 0.
Oh,
right?
okay.
As the denominator is tending to 0, numerator should also tend to 0 if it has to exist.
Okay.
So limit exists karna hai to 0 by 0, and then we will use L'Hopital rule.
So the whole of 14 cos 14x plus 8 cos x is tending to 0, right?
Should tend to 0 in order that limit exists, should tend to 0 as x tends
So
to 0.
then how does the x tends to 0 come?
As x tends to 0. See, that is where we are checking the limit, right? As x tends to 0, it should be like now as x tends to 0, is taraf aana, left side aana, and this 14 cos 14x plus a cos x should also tend to 0.
Oh, okay.
Okay.
So will this be the case like all the time?
Yeah, of course. If your limit is being, if I said if your limit exists at x is equals to 0, and in denominator you are getting 0 somewhere, then obviously your numerator will also tend to 0.
Okay.
Making it as an indeterminate form, so that you can use L'Hopital rule and you can find the limit value.
Okay, sir.
Okay. Yeah.
Thank you, sir.
Okay. Thanks then, and be prepared for mock and don't come without preparation. Okay. We are keeping it on Sunday evening because you will get Saturday and Sunday to prepare. So try to prepare whatever you understand. You try to prepare, solve few problems, solve again graded assignments, practice assignments, and
Sir, you bless us also to get that intelligence. You bless us so that we'll get intelligence to grab quickly.
Okay, thank you, sir.
Thank you very much, sir.
Thank you, sir. Have a great day, sir.
Okay, have a good day. Yeah, meet you on Tuesday, then we will discuss more on that.
Thank you very much, sir.
Okay, yeah. Okay. Host, you can end the session.